Hello, everyone. Imagine lying on the ground, away from the light pollution, watching the sky. The dimension of stars beloved kilometers away may seem as if they are not moving. If you look long enough, you will realize that they are actually in motion. The same is true for our planet. No, we are not talking about the world itself and its surrounding environment. We are proceeding from a movement that takes place kilometers below where we reach to watch the stars. From the core of the Earth. One of the most difficult points in the region where the details are under 6,378 kilometers under your feet. However, according to an article published recently, it has stopped returning internal benefits and may be redirecting in the opposite direction. Wow, this sounds like a big disaster news. What is the reason for the kernel to stop? Will we feel the effects of this situation? Let's look for answers to these questions together in this video. Xia Odong Song and Yi Yang from Beijing University tracked the movements of the inner core and analyzed the seismic waves from earthquakes in the last 60 years, claiming that the Pluto-sized inner core is no longer spinning in the same direction as the planet, but in the opposite direction. Since the inner core is close to impossible to investigate, most research on the inner core has been the subject of debate in the scientific community. Earth's inner core, which scientists describe as planet within a planet, was discovered in 1936 by Danish seismologist Inge Leifman by examining seismographic data in New Zealand. The core, made of iron and nickel, has a diameter of 1220 kilometers and has a temperature of 6,000 degrees, which is almost equal to the temperature of the sun's surface. Due to the huge pressure exerted by the mantle and the Earth's crust on the core, the inner core is solid, but the pressure on the outer core surrounding the inner core is less, which is 20 to 60 kilometers thick, which is in the liquid state. At the heart of our planet is a war that has been going on for millions of years. Earth's magnetic field, produced by the rotating iron current in the outer core, pulls the inner core towards itself, causing the core to rotate, counteracting this strong pull by the desiccing gravity it exerts on the mantle layer, grasping the inner core and slowing its rotation. Scientists who believe that the inner core moves back and forth like a swing relative to the Earth's surface stated that this swing cycle changes direction every 70 years. In the mid-1990s, Xia Odong Song was one of the first scientists to suggest that the inner core could rotate at a different rate from the Earth's surface. Since then, seismologists have found evidence that the inner core's rotation can both speed up and slow down. The first evidence of this oscillation was recorded around Alaska in 1960, and scientists have been studying the change in seismic waves for decades with these data. Considering that it is 4 billion years old, it is useful to know that the activity in the center is not unique to our age. As with this new study, some unusual data were found in the early 1970s. The results show that the inner core rotated in a different direction between 1969 and 1971, and in a different direction between 1971 and 1970. So what? Won't there be scary earthquakes, huge tsunamis, or volcanic eruptions all over the world? The answer is no for now. The researchers reported that the rotation in question is in line with small changes in the time it takes for the Earth to rotate around its axis. The difficulty of investigating the inner core and the lack of available evidence have made scientists wary of the findings. So far, little evidence has been found that the inner core has any effect on the surface inhabitants. On the other hand, Scientists state that they believe there is physical evidence between the layers of the Earth from the inner core to the surface. However, most modeling on this subject has not been able to fully explain what is happening in the inner core. We hope our study will encourage some researchers to build and test models that treat the entire Earth as an integrated dynamical system, said study authors Exia Odong Song and Ya Yang. Tunneling through the center of the Earth means overcoming the mind-blowing pressure created by 6.6 sextillion tons of rock. This enormous pressure is 3 million times the pressure you would feel at sea level. If we were to open a 7.5 meters wide tunnel, we would have to drill 580 million cubic meters of rock with our imaginary SuperTech drilling machine. The deepest well, dug with the aim of reaching the deepest point we can go in the crust layer of the world, is the Kola Deep Drilling located on the Kola Peninsula near the Norwegian border of Russia. During the project, several side channels were opened from the main artery, and the deepest of these is the She Tree Trench with a depth of 12,262 meters. As of 2003, the drilling with a diameter of 214 millimeters at 8,578 meters was closed in 2005 due to lack of resources. Although it was active, it was abandoned in 2008, and the technical materials used were sold as scrap. While traveling to the center of the Earth is so difficult, scientists are working on many models of understanding the inner core. One of them, in a recently published study, is seismologist John Vitale from the University of California. This is a very careful study by scientists using a lot of data, but I think none of the models explain all the data very well. Evaluated as, that's all for now. What do you think about this study? Do you think we will be able to descend into the heart of the world one day? What awaits us there when we can reach it? Please share your ideas with us. Don't forget to subscribe and ring the bell for more videos with this kind of content. See you later. Hello, everyone. Black holes challenge science so much that even some scientists doubt their existence. Despite black holes' terrible reputation, we've never actually seen them. We know that black holes exist all over the universe, in every corner of our galaxy. However, that doesn't mean they are easy to find. You can almost imagine how difficult it would be to try to find a freely floating black hole in the fabric of space-time with a black background. This situation is also paradoxical because scientists believe that the birth of black holes was some of the brightest explosions in the universe. In fact, black holes rise from the corpses of stars that have exploded many times larger than our sun. The star that burns for 10 million years collapses into itself within seconds, forming a black hole. With this collapse, the outer region of the star hits the core, triggering a huge explosion, a supernova. We see this explosion, but we cannot see the rest. A dead core where the immense mass of a star, thousands of times larger than the sun, is compressed into an infinitesimal space. From this dead core, a high-mass black hole is born. The gravitational flow around the black hole is so strong that nothing can escape from it, not even light. But how can scientists claim that black holes exist when we can't see them? In fact, we can say the same about the existence of the atom. We knew they existed for decades, centuries ago. We even had the chance to see one of them with some kind of imaging device. The same goes for black holes. Just because we can't see it doesn't mean it's not there. Not being able to see black holes, but knowing they are there, is a possibility. Just as we know that the wind is there, even though we cannot see the air. Weather is invisible, but when the wind blows, its effects can be measured. The same is true for black holes. You just have to know where to look even when they don't emit light. Black holes are enormous sources of X-rays, and this is because as objects approach a black hole, they are accelerated by gravity and can heat up to millions of degrees. Millions of degrees of gas gives you loads of X-rays. To find and measure these X-rays, scientists applied to the New Star Space Telescope in 2017. Astronomers discovered a powerful X-ray burst in the star cluster 47 Tucana. When the scientists analyzed the data, they realized they were looking at two objects orbiting very close to each other. All they could see was a star disintegrating, and the disintegrating gas spiraling into a very dense, very dark object. Even an unrelated person might notice that there is something strange going on here. One of the objects was pulling matter from the other and depositing it inside. This causes the object to emit strong X-rays, and these X-rays can be used to trace trajectories and thus infer mass. When scientists calculated the size and mass of the two objects they found, they encountered the first object's fading corpse of a sun-like star. When they examined the second object, they discovered that although it was small, it had the mass of a giant. Was the second object an elusive black hole? What we are talking about here is an object that is very large, very small, and has very intense gravitational pull. However, an object that looks this complicated does not necessarily have to be a black hole. There are many different ways to create such an object. There is another type of ultra-dense object in the universe called a neutron star. The neutron star is one of the forms in which stars can end their lives. The gravitational pull of a neutron star is enormous, pulling in gas, dust, and asteroids. But light can still escape from it. For this reason, black holes and neutron stars are considered cousins. But a neutron star doesn't have enough mass to spiral out of control. You can think of them as narrowly avoiding turning into a black hole. The tiny object discovered by NuSTAR, which focused on detecting high-energy X-rays, indeed has an enormous mass. But size and mass alone aren't enough to prove it's a black hole. Cosmologists need more evidence on this. They can't see black holes. But is there another way to discover them? What if we could hear black holes instead of being able to see them? Now we ask you to think of two cars colliding. Boom! When they collide, they emit sound. And we can tell if this collision has occurred and even how far away it is. That's what happens when black holes collide. So by listening to a black hole collision, we can get an idea of their existence. Black holes are some of the densest objects in the universe. Therefore, we should be able to hear and measure the waves created when they collide. Legacy named Long Interferometry Gravitational Wave Observatory tuned to listen for waves that can come from 1 billion light years away. In 2017, the observatory heard a tremendous crash. Two very large objects collided at almost the speed of light, and one of the most energetic events we have ever witnessed in human history took place. Two ultra-heavy, ultra-dense objects have been observed orbiting each other, tossing powerful gravitational waves through space. The closer they get to each other, the more gravitational energy they emit. Finally, they collide with enormous energy, realizing one of the most violent events in the universe. At the end of this collision, LIGO continues to send enormous gravitational waves rippling through intergalactic space until it detects them. Listening to gravitational waves is like listening to a musical instrument. You can tell the size type of musical instrument if it produces certain tones or certain vibrations. So who plays this musical instrument? That's all for today. Don't forget to like and subscribe to our channel for more videos. We try to discover the secrets of space. See you in other videos.
Hello, everyone. An international team of astronomers, including scientists from the Harvard-Smithsonian Astrophysics Center, has discovered the most distant galaxy ever discovered, 13.5 billion light-years from Earth. However, scientists have a doubt about this galaxy. Let's take a closer look at this discovery. For astronomers, discovering the first generation of stars and galaxies in the universe has been a holy grail in astronomy. But the problem is that the lights of these first-generation galaxies are very dim and largely redshift. This makes it increasingly difficult for us to discover them. Until 2022, the farthest known galaxy was James 11, located in the constellation of the Big Bear. The galaxy, which is thought to exist only 400 million years after the Big Bang, is 32 billion light years away from us and has been redshifted significantly. But now, astronomers have discovered a new galaxy 100 million light years away. They observed the most distant galaxy ever, with data from the telescopes at around 1200 hours. This ancient camel in the constellation of Sextans was named odd by scientists. With the information we have, we can say that Dun is a mystery in itself. First, the visible red color of the galaxy is due to the redshift phenomenon. This phenomenon is the name given to the extension of the wavelength of light scattered from stars, galaxies, or supernovas in space until it reaches us, and indirectly, the shift of light to wavelengths corresponding to red color. Likewise, if the wavelength of light is shortened, it is called blue shift. According to Hubble's law, the further away a galaxy is in deep space, the faster it moves away. The redshift phenomenon allows astronomers to determine how far the galaxy is from us. The light journey to Dun is 13.5 billion light years. However, if we take into account the expansion of the universe, the appropriate distance is 33.4 billion light years. In short, exploring this far-flung red galaxy was no easy task. Astronomers used the Spider Space Telescope, Subaru Telescope UK Infrared Telescope, and Vista telescopes to explore Dun and analyze nearly 1,200 hours of data. The researchers, who had to find Dun among more than 700,000 objects, made it as difficult as trying to figure out the nationality of the shit coming from afar on a foggy day. They used the phrase, however, when it was calculated that the new stars were more than expected, scientists doubted what the discovered object was and started to produce theories. Answering questions about the nature of an entity this far away can be difficult, said astrophysicist Fabio Pucci of the Harvard-Smithsonian Center for Astrophysics, who evaluated the galaxy structure, commented as a result of the researches, scientists came up with two theories about what this ancient galaxy could be. The Dun galaxy was either a starburst galaxy or a mighty quasar. A starburst galaxy consists of cold gas reserves formed in giant molecular clouds in the galaxies, and an extremely high rate of star formation is observed within them. Star formation rate is an important parameter in galactic and extragalactic astronomy. Starburst is a stage in the evolution of a galaxy that occurs for different reasons. Even galactic interactions can lead to a starburst, as in the Antenna Galaxy. These two galaxies have been merging for the last 100 million years, and their star formation rates have increased dramatically due to this interaction. In this image, the blue regions represent high star-forming activity, stating that the ultraviolet waves emitted from the galaxy are extremely bright. Scientists stated that so much light could be produced by more than 100 stars per year, and this figure is 10 times more than expected for a galaxy in the early stages of the universe. But there is an explanation for this. Pucci noted that this may be due to the fact that the first stars formed in the universe were larger, brighter, and hotter than modern stars. The first generation stars that formed were significantly hotter and brighter than modern stars. If that's the case, we may be looking at light from so-called population II stars that contain little or no elements other than hydrogen and helium. The second possibility for done is that this light was emitted by a mighty quasar. Quasars are the most powerful objects in deep space and contain a high-mass black hole feasting on the material surrounding the core. Gas in the disk falling towards the black hole heats up due to friction and releases energy in the form of electromagnetic radiation. The most powerful quasars can be thousands of times brighter than a galaxy like the Milky Way. Dunn's brightness and star formation rate were quite surprising. This meant that the universe contained its first stars. On the other hand, this object could be a black hole, and if this object is indeed a black hole, it will be the most massive and closest in age to the Big Bang ever discovered. Researchers are considering using the James Webb Space Telescope to peer into the distant universe, and they hope future observations will shed light on the nature of this mysterious planet. That's all from us for today. What are your thoughts on this discovered galaxy? Please share with us in the comments section. Don't forget to like our video and subscribe to our channel for more videos. See you later.
Hello, all dear space enthusiasts. We all know that you are looking forward to the movie Barbie, which will be released on July 21 and starring Margot Robbie and Ryan Gosling. However, a supermassive black hole that has been emitting radiation in the depths of the cosmos for 800 days and which scientists call the terrible Barbie, is currently the favorite of the astronomy world. This event, which scientists call the most powerful cosmic explosion ever witnessed, has taken everyone by surprise. Join us on this cosmic journey as we explore the enchanting dance of destruction, a celestial battle that unleashes unimaginable power and unleashes the true power of a black hole. Let's start. Far, in the heart of a galaxy far away, a stray star continued to soar peacefully against the cosmic landscape. But unaware of this unsuspecting celestial being, a hidden monster lurks nearby. A black hole symbolic of darkness and the relentless grasp of gravity. As the star unwittingly approaches its impending doom, unfathomable forces take action. The gravitational forces unleashed by the black hole's chains begin to distort the surrounding space-time, creating an invisible vortex of cosmic dimensions. Feeling the pull of the black hole's immense gravity, the star begins its tragic descent into the insatiable abyss. And so begins the celestial ballet. A story as old as time itself. A terrifying event occurs in the universe and a tremendous energy is released for a short time. The event then disappears into the darkness and the universe returns to normal. The planets continue to spin and the stars continue to shine silently. These short-lived cosmic events are known as transients and include events such as supernovas and gamma-ray bursts. Due to the energy released during a typical supernova explosion, a ball of light can be formed that is brighter than the light emitted by entire galaxies, and more energy is thrown into space than our sun would emit in its total lifetime of 8 billion years. Supernovas happen so suddenly that a spot in the sky that wasn't there just a few hours ago can shine like a lighthouse in a matter of hours. But supernovas seen in the sky are not like other stars in the sky. They are the remains of a dead star, and statistically, every second in the universe, about 30 stars scatter their material in a supernova explosion. Well, remember, we said in our previous videos that the universe isn't exactly a quiet place? Gamma bursts, on the other hand, are defined as one of the brightest, most powerful, sudden, and wildest events known in the universe. The energy released in gamma bursts can be so powerful that if it hits, it can completely wipe out a galaxy or system. And these bursts occur between a few milliseconds and a few seconds. In a typical gamma burst, 1 in 20,000 of all the energy the sun can deliver in its lifetime can be emitted in a few seconds. Calculations show that in or around a galaxy such as the Milky Way, a gamma burst may occur, on average, once every 5 million years. As it turns out, temporary outbursts are quite common, but some may defy explanation. Take, for example, the ephemeral phenomenon known as Zeitfonia Borby, nicknamed Scary Barbie. The distant object, a surprisingly bright flash of light that lasted for more than 2 years, was discovered while lurking inside an enormous dataset collected by computer-guided telescopes. After finding the brightly lit patch of sky in the data and cross-referencing observations by other telescopes, astronomers realized they had stumbled upon one of the most powerful cosmic explosions ever witnessed. They reported their findings on the Arxiv preprint server April 17, and their paper has been accepted for publication in the Astrophysical Journal Letters. The terrifying Barbie was born from the final death throes of a star being torn apart by a supermassive black hole. The dreaded Barbie was actually first observed in 2020 and has continued to be observed in a range of wavelengths thereafter. Scary Barbie is an unusual temporary for 2 reasons. The first is that it lasted far longer than typical transients. A fast radio burst can take seconds. A supernova's afterburn can be observed for a month, but Scary Barbie has lasted more than 800 days and is still visible. The terrifying Barbie has been burning incandescent for over 2 years, and there is no sign of it going out. The second oddity is that it has such terrifying energy that it dwarfs a starburst galaxy. The terrifying Barbie is 1,000 times more energetic than the brightest supernova. It's really hard to imagine the size of this temporary. One of the things that makes the Scary Barbie weird is that it doesn't seem to be associated with a particular galaxy. Supermassive black holes usually tend to lurk in the center of their galaxy. However, in the data obtained so far, there has been no clear information about the galaxy to which the black hole is connected. By turning telescopes like Hubble and James Webb into Scary Barbie, scientists aim to answer this question. Because the dreaded Barbie's light came from a distant region of the sky it traveled about 7.7 billion years across the expanding fabric of space-time, astronomers were unable to detect the event directly. Instead, researchers developing a machine learning system called the Recommender Engine for intelligent transient tracking scanned data from multiple observations before finding the extremely bright light source. Using the Lick Observatory in California and the Keck Observatory in Hawaii, the researchers were able to better characterize the light coming from a transient event. This study is a great example of how public data and AI data mining can lead to unexpected discoveries. These discoveries can only be possible by making the data public and developing tools to filter that information. As this latest study shows, science works best when everyone can participate. Who knows what other amazing things are waiting to be discovered in public data? That's all from us for today. What cosmic event did you want to explore in space? Please share your ideas with us in the comments section. Don't forget to subscribe to our channel and turn on the bell notification in order not to miss the news from the cosmos. See you in another video. Hello, everyone. Black holes are among the formations of the universe that remain obscure. They range in size from a tiny pinpoint to billions of widths. According to astronomers, there are around 40 quintillion stellar mass black holes wandering around in the universe. Stellar mass black holes are found in the observable universe and make up ones of all matter. Stars with a mass thousands of times greater than the Sun at the end of their lives begin to fuse increasingly heavier elements such as silicon and magnesium in their cores. As this fusion process begins to form iron, the star begins to violently self-destruct. The iron takes in more energy for melting than it gives out, causing it to lose its ability to propel against the powerful gravitational forces produced by the massive mass of the star. Then it collapses into itself, first packing its core and then all matter close to it into an infinitely small and infinitely dense singularity point. After all this strife, the star turns into a black hole, and beyond a boundary called the event horizon, nothing, not even light, can escape the black hole's strong gravity. Black holes, as their name suggests, are black. In an endless darkness, it is impossible to see a black hole ready to swallow everything in its path. However, we can see the strong gravitational force exerted by the black hole on the stars and gas around it. If a star is orbiting at a certain point in space, astronomers can tell from the movements of that star whether it is orbiting a black hole. Studying black holes can give us a whole new perspective on the universe. In recent months, astronomers announced that the newly discovered pair of supermassive black holes is the closest to colliding black hole. In today's video, we will examine the details of this news together with you. Astronomers said in a paper published June 9 in the Astrophysical Journal at the American Astronomical Society meeting in Seattle that the newly discovered supermassive land announced that the whole pair is the closest black hole to collision. Although these two supermassive black holes are cosmologically only 750 light-years apart, they will not merge for several 100 million years. Meanwhile, the astronomers' findings provide a better estimate of how many more supermassive black holes in the universe are close to colliding. This advanced count will help scientists listen to a cosmic-wide choruses of intense space-time fluctuations known as gravitational waves, the largest of which is the product of the close collisions of supermassive black holes following galaxy mergers. Detecting this gravitational wave background will improve estimates of how many galaxies have collided and merged in the universe's history. Because of the small separation between the black holes, astronomers were only able to tell the difference between the two objects by combining multiple observations from 7 telescopes, including NASA's Hubble Space Telescope. Although supermassive black holes cannot be seen directly with an optical telescope, they are surrounded by bright stellar bundles and hot gas that is attracted by their gravitational pull. The fact that astronomers found this black hole pair so quickly means that supermassive black holes that are close together may be more common than we thought because we found both and we didn't have to look far to find them, said Menger Lelling, co-author of the study. The newly discovered supermassive black holes are in a mixture of two colliding galaxies about 480 million light-years from Earth. Massive black holes live at the centers of most galaxies and grow by swallowing gas, dust, stars, and even other black holes around them. The black hole Sagittarius, which has a mass almost 4 million times that of the Sun, is located at the center of the Milky Way, just like other galaxies. The two supermassive black holes found in this study are really heavy balls. They are 200 million and 125 million times larger than our Sun, respectively. Black holes came together as their host galaxies crashed into each other. Eventually, they will begin to orbit each other, the orbit narrowing as gas and stars pass between the two black holes and steal their orbital energy. Eventually, black holes will begin to produce gravitational waves much stronger than previously detected, and they will slam into each other, forming a jumbo-sized black hole. Some of the energy created by the collision or merger of two black holes is released into space-time in the form of very strong gravitational waves. We can learn about these strong gravitational waves by measuring them with precision instruments on Earth. In 2019, a large black hole collision was discovered thanks to the gravity detectors LIGO and Virgo. About 12.81 billion light-years away from us, these black holes, 66 and 80, 5 times the size of the Sun, collided to form a new black hole with 100 solar masses. It was observed that the newly formed black hole reached a speed of 200 km per second with the thrust of the merger. From the collision site, NASA's Fermi X-ray Space Telescope picked up a weak gamma-ray signal with a delay of 0.4 seconds. We would like to clarify here. LIGO, the Gravitational Waves Observatory, observed in 2015 that two black holes, 136 and the other 29 solar masses, merged to produce a larger black hole. In the intervening 5 years, the sensitivity of LIGO has been increased, and it has been made much more sensitive by working with the Virgo Gravitational Waves Observatory in Italy. We've since added 50 black holes to our list of merging black holes. However, until May 2019, we could not see a single signal from black holes. In addition, Palomar Observatory's Transient Celestial Events facility detected a rapidly increasing magnetic field burst in the area where the merger occurred. When scientists combined all this, they realized that black holes were actually colliding inside a larger accretion disk. What is more interesting is that this event took place 7 billion years ago. If we go back to our topic, previous observations of merging galaxies had only seen one supermassive black hole. Because the two objects were so close together, scientists weren't able to clearly separate them to observe with a single telescope. The new research, led by Michael J. Koss of Eureka Science in Oakland, California, combines 12 observations from 7 Earth-based and orbiting telescopes. While a single observation was not enough to confirm their existence, the combined data ultimately revealed 2 different black holes. Mingarelli, along with visiting scientist Andrew Casey Clyde of the Flatiron Institute, say they estimated the universe's population of merging supermassive black holes using the new observations and found that it could be surprisingly hot. They speculate that supermassive black hole pairs are abundant and produce large amounts of ultra-strong gravitational waves. All this fuss should result in a high gravitational wave background that is much easier to detect if the population is smaller. That's why the first detection of background noise from gravitational waves could happen very soon, Mingarelli says. What do you think about this discovery? Please share your ideas with us in the comments section and ring the bell to be notified of upcoming videos. See you in another video. Hello, everyone. In a groundbreaking discovery, astronomers have found the closest black hole to us so far. Part of a binary system orbiting a sun-like star, This object is a new source of many problems for scientists. Initially, astronomers thought it was a normal system consisting of only two celestial bodies. But when they studied the properties of the star and how it revolved around the black hole, they quickly realized that something unusual was going on there. They had never seen a black hole and a star locked in such a binary system before. After all, the gravitational power of black holes is a fact known by everyone. What could be going on around a black hole where even the speed of light is not enough to escape? Let's take a closer look at this black hole that was discovered with you. For this discovery, astronomers used data from the Gaia mission. Gaia is not as popular as Hubble or the James Webb Telescope and is unknown to many people. But there is no need to panic. Gaia does not mind these things and will continue to contribute to the world of astronomy silently and proudly. Gaia, the observatory of the European Space Agency, has changed the course of astronomy with its extensive sky surveys in the last few years. After launch in 2013, it creates a three-dimensional map of the Milky Way through astrometry, pinpointing the positions, velocities, and orbits of other astronomical objects to understand the origins and futures of stars in our galaxy. Gaia shares its position with the James Webb Space Telescope as it currently orbits the Sun at the all-too-Lagrange point 1 million miles from Earth. Since the observatory's launch, it has released 3 datasets, with the last in 2022. Thanks to these datasets, Gaia has revolutionized astronomy, and astronomers publish many research papers based on its data every day. Astronomers using the Gemini North Telescope in Hawaii, one of the twin telescopes of the International Gemini Observatory, operated by NORAD, deepened their investigation after noticing a star's unusual motions, and Karim El-Badri of the Max Planck Institute for Astronomy at the Harvard-Smithsonian Center for Astrophysics and his team announced that they had discovered the closest black hole to Earth after their investigations. This distance of the black hole makes it 3 times closer to Earth than the previous record holder in the Monoceros constellation. Researchers named this celestial body Gaia B H1. Scientists were able to detect this black hole thanks to its companion star. According to the discoveries made, it was discovered that this star is in an orbit around the black hole at the same distance as the Earth-Sun orbit. Well, a question may come to your mind. If it was so close, why didn't we discover it much earlier? This is because the black hole is not feeding. Normally, black holes swallow objects around them, creating an X-ray, which makes them easier to discover. These so-called feeding black holes, despite their name, become quite bright as they feed, and the rays they emit can be detected thousands of light years away. Although unfed black holes outnumber fed ones, they are more difficult to detect because there is no light emitted from the accretion disk. The researchers' first clue to the existence of Gaia-phone came from detecting the strange movements of a nearby star in the constellation Ophiuchus. Using data from different telescopes, they concluded that the unusual motions of the star were due to the gravity of an unknown massive object. Binary systems of this type are extremely rare, and the newly discovered structure is the first known example within the confines of the Milky Way galaxy. The black hole discovered in our cosmic backyard raises questions in the minds of scientists. The main star that makes up Gaia-phone should have a mass 20 times greater than the Sun. But if this were the case, the star should live for several million years, which is too low for a stellar lifetime. It should have been swallowed up by its neighbor while it was in the supergiant phase before it went supernova and turned into a black hole. But the star that should have been swallowed is still there, as it turns out. For a better understanding of this system, the lead author of the article, astrophysicist Kerem El-Bedri, says, "Take the solar system and put a black hole where the sun is and the sun where the Earth is, and you get the system. A sun-like star orbiting a stellar mass black hole in our galaxy has been detected unambiguously for the first time. So why is he still there, and how can he go about his daily life despite the star accompaniment? The next data transfer from the Gaia observing satellite is expected in 2025, and perhaps the new data could help us answer these questions. That's all from us for now. Do you think we will be able to discover new things about this black hole in Gaia's next dataset? Please share your views with us in the comments section. Don't forget to like our video and subscribe to our channel for more videos with such content. See you in the next video. Hello, everyone. On a cold, dry February 11th night, the Zwicky Transit Facility at Palomar Observatory near San Diego, California, discovered a strange flash of light in the sky. Light has been traveling towards us for more than 8.5 billion years. Yes, more than half of the universe's lifetime. The telescope sent a warning about this unusual flash of light right after the discovery. To witness this rare phenomenon, astronomers set in motion several telescopes around the world. Then telescopes from around the world, including the Hubble Space Telescope and the NICER X-ray instrument aboard the International Space Station, observed this unusual flare at various wavelengths. After 2 more nights of work, the astronomers reported the source to the ephemeral name server, and the system gave it a cool, formal name, AT2022-CMC. When astronomers observed and analyzed this source across the entire electromagnetic spectrum, they realized they were witnessing an extremely rare cosmic event. This strange flash of light was captured at the Zwicky Transit Facility. It was formed by a star-eating black hole in the far corner of the universe. This made it visible to our telescopes as the jet of stellar remnants exploded directly towards Earth. But how did astronomers learn it was a star-eating black hole? What happened a few minutes after the black hole destroyed the star? Finally, and most importantly, why was this discovery so important in astronomy? Let's explore the answers to these questions together. When you look at the stars at night, you may have noticed how calm the sky is. But appearances can be deceiving because space is not a quiet place at all. It is full of chaos and explosions. Stars die. Meteorites collide, and one of the unlucky stars stuck in my own state becomes prey to the hungry black hole. These acts of violence in the cold darkness of deep space generate powerful bursts of light, and astronomers can track these fluctuations of light to theorize about what's causing it. Also known as the tidal distortion flare, this event happens when the aforementioned unlucky star gets spaghettified when it gets close enough to the black hole, being separated by the tidal force of the cosmic giant. This is similar to the moon's magnetic field pulling the oceans on Earth, but with a much more power. Pieces of the star stretched out like spaghetti by the black hole are captured by a rapidly spinning disk around the black hole. Pulled by strong gravity, matter falls toward the central black hole while being fed by surrounding gas and dust. However, instead of falling into the black hole, a small fraction of the particles accelerate to nearly the speed of light and are scattered in two narrow beams along the black hole's spin axis. Such dynamic events open an unprecedented window into studying how a supermassive black hole can swallow any object. That's why astronomers are constantly looking for such events in the sky. The Zwicky Transient Facility is currently one of the most comprehensive temporary research facilities to study this phenomenon. In fact, modern astronomical studies discover this type of stellar spaghettization roughly once or twice a month. However, only 3 of them have been seen producing powerful jets before, most recently in 2011. When the AET 2022 CEMC was discovered, astronomers first studied the source in the electromagnetic spectrum. This event was extremely bright, especially at X-ray wavelengths. The X-ray emission was radiating more energy in 1 second than the sun did in 10 million years. X-rays were also highly variable, varying in brightness on timescales as short as 15 minutes. In particular, it also had strong emission at radio and millimeter wavelengths and became brighter over time. In astronomy, the smaller the size, the brighter the object. About 4 days after discovery, the astronomers recorded a dramatic red color rise followed by decay. The color then slowed down and became more blue. The rapid evolution of this extraordinary luminosity across the entire electromagnetic spectrum on a time scale of several days made the AT 2022 CEEMC extremely unusual. The light produced by the AATT 2022 CEMLC began its journey when the universe was about 1/3 of its current age. About 8.5 billion years ago, astronomers discover about 100 energetic transients each night, but since none of them have such unique properties, they continued their search, wanting to know what caused this bright flash of light. The event began when an unfortunate star approached the supermassive black hole in an almost parabolic orbit and disintegrated in a stream of gaseous debris. About half of the mass remained around the black hole, producing powerful shocks at its self-crossing point. The resulting gas then circulated around the black hole to form an accretion disk, and its rapid spin produced a pair of relativistic jets. The event occurred during a redshift of 1.19, or about 8 billion light-years away. This makes the A2022 CEMC the most distant jet tidal disturbance event discovered to date. So bright that astronomers witnessed a sun-like star be destroyed by a black hole 1,000,000 times its mass. Researchers believe the object is at the center of a galaxy not yet visible because light from the AET 2022 CEMLC is eclipsing the galaxy. But future space observations with the Hubble or James Webb Space Telescopes may reveal this shadowed galaxy when it eventually disappears after the transient event. We last saw such an event more than 10 years ago, but were unable to observe it. The black hole in such action was visible for the first time at optical wavelengths in the night sky. This cosmic event could be a new way to detect jet-firing Ds across the vastness of space, allowing us to more deeply study these rare events and the black holes that trigger them. Daniel Purley, an astronomer and another co-author from Liverpool John Moores University in England. So far, the few known jet DDs have been initially detected using high-energy gamma ray and X-ray telescopes. But this was the first to be discovered during an optical survey, he added. That's all from us for now. What do you think about this issue? Do not forget to share your ideas with us in the comments section. Don't forget to like our video and subscribe to our channel for more videos like this. See you soon.
Hello, everyone. Another mind-boggling thing about deep space is the estimation of how big it is. For example, our own galaxy, the way we treat the Milky Way. The Milky Way galaxy is a huge collection of stars, dust, and gas. The Sun is about 25,000 light-years from the center of the galaxy. Even if you traveled at the speed of light, it would take you about 25,000 years to reach the center of the Milky Way. The Milky Way got its name from a Greek myth about Hera spewing milk. However, the galaxy is known by different names in different parts of the planet. In China, it is called the Silver River, and in the Kalahari Desert of southern Africa it is called the Backbone. Studying the Milky Way used to be very difficult. Astronomers have described it as trying to understand the size and structure of the forest while being lost in a dark forest. We don't know how to get perspective from a vantage point on Earth, but two groundbreaking space telescopes launched since the 1990s helped usher in the golden age of Milky Way research. The galactic disk extends beyond the bulge, 100,000 light-years across and 1,000 light-years thick. This structure is home to the vast majority of the galaxy's stars, including our Sun. Known as the supermassive black hole, Sagittarius A is located at the center of the Milky Way. It scatters stars, stardust, and gas clouds in the disk. Discovered in 1974, the black hole has a mass of 4 million suns and can be seen in the sky with radio telescopes near the constellation Sagittarius. Everything else in the galaxy revolves around this powerful portal to oblivion. The densely packed region of dust, gas, and stars surrounding it is called the galactic bulge. The galactic bulge is peanut-shaped and 10,000 light-years wide and is home to 10 billion of the Milky Way's total of about 200 billion stars. Beyond the bulge is the galactic disk. This 100,000 light-years wide and 1,000 light-years thick disk is home to the vast majority of the galaxy's stars, including our Sun. Stardust and gas clouds scatter stars in the disk. The stars in the disk orbit the galactic center, forming spiral arms that spring out from the galactic bulge. The mechanisms leading to the formation of spiral arms are still being investigated today. However, the latest findings show that these arms are within 13 billion years of evolution of the galaxy. It shows that it formed and dispersed in relatively short periods of time, up to 100 million years. Our Sun is about 26,000 light-years from the black hole Sagittarius A, located roughly at the center of the galactic disk. It takes 230 million years for the Sun to complete one full orbit around the galactic center and moves at 828,000 kilometers per hour. All this is surrounded by a spherical halo of dust and gas, twice the diameter of the disk. Astronomers believe that the entire galaxy is surrounded by a halo of dark matter. But dark matter, which can be indirectly inferred from the gravitational effects of stars in the galaxy, does not emit light. According to calculations, this matter makes up 90% of the galaxy's mass. Clutter of the Milky Way galaxy, including dark matter. It is scattered among the visible celestial bodies in the galaxy, along with 200 billion stars and huge gas clouds that fill the stars. Located in the center of the Milky Way, these objects were so large that researchers were shocked when they measured their size. What high-energy radiation they emitted. Astronomers working with the Fermi Gamma Ray Space Telescope have discovered that these two massive blocks, known as Fermi bubbles, are rising from the core of the Milky Way galaxy. Fermi bubbles stretch more than 25,000 light years above and below the plane of our galaxy. Glaciers in Antarctica have reported 10 super high-energy neutrinos originating from bubbles, prompting some astrophysicists to think crazy subatomic interactions are taking place. So how did the Fermi bubbles originate? This is totally confusing. Normally, it is very difficult to make large, hot gas clouds for stars because they require significant energy resources. A typical galaxy does not have a kind of energy that could radiate hot gas over 25,000 light years. The peculiar orientation of the Fermi bubbles, which lie equally above and below our galactic center, is a strong clue that they may be connected. Perhaps the black hole Sagittarius A, located at the center of our galaxy, began to engulf a large celestial body millions of years ago. The turbulence experienced in the polar regions throws most of the matter out of the galaxy. These particles spread out and thinned while trying to escape to a safe zone, but have remained energetic until today. Astronomers have observed such a phenomenon in other galaxies, and it is not known whether the Milky Way black hole has an active eruption today, but it may have happened millions of years ago. Approaching the black hole, the star broke into pieces and released all this strong gravitational energy in a single violent event, causing bubbles to form, but maybe he was looking at it from the wrong place. Maybe these bubbles had nothing to do with the disintegration of a star. Maybe because of the abundance of stars in the core. Maybe dozens or star-packed with hundreds of teeth went supernova at the same time and ejected these gas clouds beyond the galactic core. We may never be sure which is the case, but the bubbles continue to emit an odd amount of radiation even now. We may never be sure which one is correct, but these spots continue to emit visible amounts of radiation. Although these giant blobs are so large, they cannot be seen with the naked eye because despite their high temperature, the gas inside is extremely thin, making them nearly invisible. The Fermi team was able to discover that something inside this bubble produces gamma rays, the highest energy type of light. These particles are mostly electrons, but probably in heavier elements they bounce around and emit distinctive gamma rays. But don't think that gamma ray or all that high energy particles can produce when cosmic rays collide, performing the intricate subatomic dance of matter and energy. Which neutrinos are released? Neutrinos are fundamental parts that have a speed close to the speed of light and almost do not interact when passing through materials with zero electrical charge. Neutrinos are fundamental parts that have a speed close to the speed of light and almost do not interact when passing through materials with zero electrical charge. Located at the South Pole, the Ice Cube Observatory uses 1 cubic kilometer of pure Antarctic water ice as a neutrino detector. A high-energy neutrino passing through the ice interacts with a water molecule, triggering a domino-like chain reaction that causes more familiar particles to form and glow. Despite all this, Ice Cube isn't the best at pinpointing the exact origin of a neutrino, but it has discovered at least 10 of these little ghosts coming from the general direction of the two Fermi bubbles. But whether they really come from the Fermi bubble or from other parts of the universe is still a matter of debate by scientists. Another unknown thing about these bubbles is how cosmic rays from these Fermi bubbles produce gamma rays. Perhaps there is a single set of interactions inside these bubbles that produce the right kind of neutrinos that both gamma rays and an ice cube can detect, and understanding the nature of the bubble could give us important information as we move forward. Recently, a team of researchers combed through all the available data, including results from the high altitude of water to the Rankov detector, and combined this information with various theoretical models to look for bubble. In research, scientists discovered another new structure inside Fermi bubbles, which they called Eurosita bubbles. Visible only in X-ray emissions, these bubbles are significantly hotter and less energetic than Fermi bubbles. Given their similar shapes and common midpoints, it's likely that Fermi and Eurosita bubbles have a physical connection and emerged from the same galactic fireworks explosion millions of years ago. As we mentioned earlier, scientists can't explain how this happened, but they suspect that the newly found Fermi bubble appears more like the result of an explosion. The burst of energy from the Milky Way's black hole star was countering the amount of energy potential needed to inflate them. Researchers have calculated that an energy release equivalent to 100,000 supernovas required to create these structures. This is comparable to X-ray energy oscillations observed in other galaxies with active black holes at their centers. And even if this hypothetical blast occurred millions of years ago, the effects of blasts of this size would take a very long time to heal, so the effects are visible. The discovery of new Arecitta X-ray bubbles was made using the Arecitta X-ray telescope, which travels every 6 months on the Russian, German Spectra EEG satellite. The telescope also scans the entire sky, so scientists hope that studying the bubbles could lead to the discovery of violent events in the galaxy's past. That's all for now. What do you think about these bubbles? Please don't forget to share your thoughts with us. For more such content, don't forget to like our video and subscribe to our channel.
Hello, everyone. In recent months, 3 amateur astronomers and researchers tracing the length of deep space objects have discovered a massive structure made of ionized oxygen, nearly as large as the Andromeda Galaxy. It's a little surprising that it's overlooked in this region when we're targeting all the giant telescopes and observatories we've pointed into space. Throughout history, the Andromeda Galaxy has been photographed many times by both amateurs and space agencies, and extensive studies have been made about it. The fact that the huge structure formed on the galaxy, which is so popular, has been overlooked may be an opportunity for us to review what we know. Today, we will examine the Andromeda Galaxy and the huge structure discovered on it. Let's start. Andromeda, the farthest celestial body visible from Earth with the naked eye, is 2.54 million light-years away. But don't worry, Andromeda is still on a collision course at 110 kilometers per second at around 400,000 kilometers per hour. Sorry, no escape. After about 4 billion years, the Milky Way will converge with Andromeda and all structures will scatter chaotically, creating a new system. You guessed it, such a collision would mean the end of our solar system. According to the models prepared for the collision of 2 galaxies, the Sun will be thrown 28,000 light-years away with the effect of the collision. What a terrible ending! But don't worry, long before this collision, the Sun will run out of fuel and die by swallowing our planet. But for now, all is well, and we have many, many years ahead of us for the collision. Please share with us in the comments which apocalypse you prefer. Now that we talked about possible death scenarios, we can get back to our topic. Since Andromeda has been imaged repeatedly by Earth-based observatories and even the Hubble Space Telescope, astronomers assumed that all that would be discovered would be small, individual objects such as nebulae within the galaxy. But the huge nebula discovered by amateur astronomers made us forget what we knew. The researchers took this photo using a backyard telescope. They were obtained with the 111-hour long exposure method. With this method, the target object photographed for hours, sometimes even days. Then the obtained data is created by stacking and combining. For 40 of the 111-hour long exposure, the team used an ionized oxygen filter out of pure curiosity that blocked all light except the blue-green glow emitted by the double ionized oxygen. In this way, the huge structure near the galaxy emerged. Thinking at first that the nebula had emerged from a technical malfunction, the team asked another amateur astronomer, Bray Falls, to make observations, and his observations independently confirmed the existence of this structure. Eventually, observations from 5 telescopes in France, California, and New Mexico convinced the team that this object was real. The team named the nebula the Stratner-Drexler Sainte Object 1, or S21 for short. For detailed analysis of the nebula structure, the team reached out to professional astronomers Stefan Keimswinger, Michael Schul, Robert Feason. It turns out that this emission feature has never been reported in the scientific literature. Even multi-wavelength image studies such as Rosette in X-rays, Galax in the ultraviolet, Planck, Iris in the infrared, and STEES in optics have not reported such emission from this structure. The results of this professional-amateur collaboration, published in the Journal of the American Astronomical Society, are fascinating, though clues to the nebula's origins remain maddeningly obscure. Now that the gas cloud has been proven, what exactly is it? The nebula's structure resists many explanations, although astronomers consider many possibilities. Since it is adjacent to Andromeda, the nebula may be related to the galaxy. Even the structure is slightly curved, as if it were moving away from the galaxy. However, this does not physically connect the cloud to the galaxy. If SO1 is indeed part of Andromeda, that means the cloud is tens of thousands of light years long, making it one of Andromeda's largest coherent structures. On the other hand, if the cloud is located in the galactic halo, which is a roughly globular collection of stars, it may be gas ejected by stellar streams there. But if it were, there would have to be an enormous amount of hydrogen around. As the hydrogen detecting filter shows, there is no hydrogen in the cloud, or at least too little to be detected. As we mentioned at the beginning of our video, Andromeda and the Milky Way are on a collision course, and there's about 2.3 million light-years between the galaxies. Well, it's a pretty short distance on the galactic scale. So one is roughly between the two, which made us think of the possibility Andromeda is so close to the Milky Way that the two galaxies may be interacting by bumping into each other as they transit through space. The diffuse gas in the two galactic halos would be compressed during the collision, forming a curved structure like the bow wave of a ship moving through water. But if that were the case, the cloud shouldn't have appeared so close to Andromeda. Instead, it should appear roughly midway in the sky between Andromeda and the center of the Milky Way. And this scenario still doesn't explain the hydrogen deficiency. Another possibility is that the cloud is physically much smaller, but much closer to us. A nebula that randomly appeared near Andromeda in the Milky Way. Planetary nebulae are shells of gas ejected by dying sun, like stars, and are often rich in hydrogen and oxygen. With the central star energizing the gas, these nebulae tend to appear bright in the light emitted by both elements. Thus, hydrogen deficiency in STEO1 does not fit this possibility. It's possible that SO1 is the remnant of a Milky Way star that exploded as a supernova, but then it should have also glowed in ultraviolet light and radio waves. But astronomers studying ancient observations of Andromeda were unable to see anything coming from the cloud at other wavelengths, including X-rays, visible, and infrared light. It is surprising, if not entirely surprising, to astronomers that something this enormous has never been detected in our sky until now. Large telescopes tend to have a narrow field of view, so objects with large apparent size are difficult to observe. Even the filters and detectors used in professional observatories are designed to observe differently than amateur telescopes. This increases the difficulty of finding objects such as SO1. Even the 3.8 meters Canada-France-Hawaii telescope, equipped with an incredible 378 megapixel camera and oxygen filter, looked at SO1 spot in the sky and saw nothing. It's impressive equipment, but it wasn't designed to see something this big and faint in the sky. The researchers report that spectral observations are currently ongoing, but until they are gone, the origin and behavior of this cloud will remain a mystery. That's all from us for now. Which object in the sky would you like to explore? Please share your ideas with us. Don't forget to like our video and subscribe to our channel. See you in another video. Hello, everyone. The James Webb Space Telescope was built to study the first stars and planets. Since its launch in December 2021, it has reshaped our understanding of the cosmos with provocative and potentially revolutionary results in early universe observations. Scheduled from July 2022 to June 2023, the first science year, a quarter of the Webb telescope's time, is devoted to exoplanets in 75 programs. Currently, astronomers know of the existence of 5,000 exoplanets, but know little about them. Thanks to the technical equipment of the Webb telescope, we now have the chance to observe these alien worlds directly. In August, astronomers announced that they had detected carbon dioxide in an exoplanet for the first time using JOST, and were looking for traces of gas filtering through the Earth's atmosphere in the light of a gas giant planet's host star. In today's video, we will explore life in space with you in the light of the Webb telescope. We didn't find much on the planets discovered with the Hubble Space Telescope, except water, because the only thing Hubble could measure was water. But JOST has a very wide range of molecules, including carbon dioxide, sodium, and more besides water. Some compounds that the Webb telescope can detect, such as methane, are closely related to metabolic processes in Earth's biosphere. This makes them possible biosignatures that could help reveal the existence of life on other potentially habitable worlds beyond the solar system. NASA's Transiting Exoplanets Survey Satellite, aka TESS telescope, had previously discovered a star called S475. However, due to insufficient data to confirm the existence of the planet, NASA focused on this star both to test Webb's power and to confirm the existence of the planet. As a result of the study, the Webb telescope confirmed the existence of the S475b exoplanet detected by TESS. The Webb telescope observed both orbits of the planet around its star. We can say a lot about what the atmosphere is not like, he says. We know that it is not hydrogen-dominated like Jupiter or Saturn. We also think it probably doesn't have an Earth-like atmosphere, but it may have an atmosphere of carbon dioxide like Venus or Mars, or no atmosphere at all, like Mercury, and all like Mercury. An additional observation expected in May will be required to better decompose the contents of the planet's atmosphere. It was stated that the confirmed exoplanet orbits a star only 41 light-years away from the constellation Octans. LELS 475b, which orbits every 2 days, is among the closest planets to Earth in size. Because LELS 475b is closer to its star than any other planet in our solar system, the planet's red dwarf star is close to half the temperature of the Sun. Researchers think there may still be an atmosphere on the planet. But even if the planet does not have an atmosphere, it is possible that there are some atmospheric components, such as an atmosphere of pure carbon dioxide. More precise measurements are needed to determine whether the planet has an atmosphere. The researchers plan to obtain additional spectral information with observations to be made this summer. Webb also revealed that the planet is several hundred degrees hotter than Earth. For this reason, if clouds are detected on the planet, it can be thought that the planet is more like Venus, which has an atmosphere of carbon dioxide and is constantly covered by thick clouds. We are at the forefront of studying small, rocky exoplanets, says Lustig Yair. We don't yet know what their atmospheres might look like, and we've only just begun to investigate. Long-term studies of rocky planets, on the other hand, are limited to worlds orbiting red dwarfs that are dim enough to avoid overloading the Webb telescope's extremely sensitive optics. Worlds such as Lao's 475b, which orbit dangerously close to their host stars, are known to be prone to glow so intensely that they can blow up their atmospheres. Yes, there is a possibility that their entire atmosphere was blown up by their stars. A key red dwarf target of interest, the TRAPPIST-1 system, located 40 light-years from Earth, contains 7 Earth-sized worlds. It is located in the habitable zone of their star. The Webb telescope's first observations are still ongoing, including observations probing the atmosphere of TRAPPIST-1. These results could go a long way toward revealing whether red dwarf worlds are truly habitable. The Webb telescope also has a telescopic attachment called a coronagraph, which is designed to block direct light from a star or other bright object. The starlight suppression power of the telescope's coronagraph is insufficient to reveal small, potentially habitable worlds, but recent studies have shown that the coronagraph's Webb telescope should allow it to see worlds up to the size of Jupiter or Saturn orbiting red dwarf stars beyond 5 times the Earth-Sun distance. This roughly corresponds to Jupiter's location in our own solar system. This analysis came about when Kellen Lawson of NASA's Goddard Space Flight Center and colleagues presented striking infrared images of a large disk of debris surrounding a young star about 32 light-years from Earth at the recent meeting of the American Astronomical Society. Astronomers are also excited about the capabilities of the European Space Agency's Gaia Observatory, another telescope in the study of exoplanets. Launched in 2013 to map the motions and positions of billions of stars in our galaxy, the telescope is also expected to find thousands of exoplanets. Using Gaia and the Volt telescope in Chile, Sasha Hinckley of the University of Exeter in England explained that her team saw an unusual planet that appears to be undergoing nuclear fusion at a distance of about 130 light-years from Earth. Hinckley says further work on the system could help astronomers draw less blurred lines between stars, planets, and brown dwarfs. Brown dwarfs are formed by the collapse of clouds of interstellar gas, but arterial light to initiate nuclear reactions to make the celestial star. It could be one of many exoplanets that could also be interesting targets for telescopes. The search for an Earth-like planet will be further crowned in 2026 by ESA's mission Plato's mission. It will look for Earth-like planets around Sun, like stars about 1,000 light-years from the solar system, and will also observe seismic activity in the stars. Project scientist Anna Hiras from ESA says several tens of such planets are expected to be found during the telescope's 4-year primary mission. We don't really know what the rate at which Earth-like planets appear. Plato will play a major role in illuminating this enigma. The Webb telescope will not be able to examine such worlds up close, nor will its successor, the Nancy Grace Roman Space Telescope, which will launch in 2027. But the Roman Space Telescope will play a crucial role, among other scientific goals, to test the advanced coronagraph technology that would be needed to produce images of Earth-like worlds orbiting Sun-like stars. This technology is the successor of both the Webb telescope and the Roman telescope. It is planned to be used at the Habitable Worlds Observatory. The Habitable Earths Observatory will launch in the late 2030s and, as the name suggests, will produce images of habitable Earth-like planets. The Webb telescope's transformative early exoplanet results remain exciting for scientists. But with the telescope's future data, our search for potential Earth-like planets will reach a whole new level. While the James Webb Space Telescope allows to explore objects in distant galaxies in close detail, the Nancy Grace Roman Telescope will be used to study larger areas. In this context, it will help us better understand dark matter and the expansion of the universe. What do you think about these developments? What secrets of the universe might the search for Earth-like planets illuminate? Please state your opinions in the comments section. Please ring the bell to be notified of more videos like this. See you in another video. Hello everyone. Today you will encounter two intriguing things from the cosmos for you. It's about what time it is on the moon, and that we can't see the Earth's rotation simultaneously. I hope you enjoy the topics we have compiled for you. Let's begin. It is an important fact for all of us what time it is when making plans in our daily lives. We decide when to go to sleep and when to meet with our friend by learning what time it is. So how do we decide in places where there is no clock? No, this is not a science fiction question, but what will happen in the next 10 years? This question comes up often when we think of dozens of moon missions and plans for a permanent moon base. What time is it on the moon base? What time is it on the moon? We're just starting to figure that out, says aerospace engineer Cheryl Gramling, who leads the position, navigation, and timing team at NASA's Goddard Space Flight Center in Greenbelt, Maryland. There is currently no independent time zone for our only friend, the Moon, which was the product of a major collision that took place 4.533 billion years ago. During each moon mission, astronomers, through their custodians on Earth, use their own time scale, which depends on Coordinated Universal Time, or UTCU, the standard by which the planet's clocks are set. They cannot synchronize. This approach, it worked when the moon hosted a handful of standalone missions, but when there were multiple vehicles working together, trouble would be inevitable. And space agencies sending vehicles for lunar missions will also want to track their vehicles using satellite navigation, which relies on precise timing signals. It is unclear how to calculate a universal moon time due to the different gravitational fields on Earth and Moon. The official lunar time can work synchronously with UTCU, or it can be completely independent of the time we use around the world. So far, in lunar missions, spacecraft have determined their positions using radio signals sent to large antennas on Earth at scheduled times. But considering the dozens of missions planned, this could become a big problem in the future. Aware of the problem, scientists were looking into how to define moon time in November 2022 at the European Space Agency's European Space Research and Technology Center in Noordwijk, Netherlands, met to draft recommendations. Patricia Tavella, who heads the time division of the International Bureau of Weights and Measures, said that decisions must be taken as soon as possible. States, if an official moon clock is not created, space agencies and private companies will find their own solutions. Tavella says, drawing attention to the urgency of the problem. The most pressing need for lunar time comes from plans to create a dedicated global satellite navigation system for the moon, similar to how GBs and other satellite navigation networks provide precise location tracking on Earth. Space agencies plan to install this lunar nest from about 2030. ESA approved a lunar satellite navigation project called Moonlight at the Council of Ministers meeting held in Paris on November 22 and 2022. and NASA established a similar project called Lunar Communications, Relay, and Navigation Systems last January. According to this project, ESA and NASA in the first place from 2024, it will attempt to derive positions on the Moon using weak satellite navigation signals from Earth-based instruments. Later, Lunar NIST projects plan to place special satellites around the Moon, each containing its own atomic clock. Georg Hahn, an engineer working on ESA's Moonlight project, says ESA is planning an initial constellation of 4 spacecraft to cover navigation at the Moon's south pole, which contains most of the water on the Moon and is a key target for exploration. An official lunar clock is definitely needed for cooperation and communication on planned Moon missions. Otherwise, there will be chaos and things will not work. We look forward to influencing the nations of the world as scientists work on the lunar clock. So, can we see the Earth spinning during the days? Except for our knowledge of the Earth's rotation and the animations made, there are ways to see the effects of the rotation of the planet, although it cannot process the rotation of the Earth simultaneously because it rotates very slowly. The first of these was the formation of night and day. If the world had not rotated, night and day would not have formed. We cannot feel the Earth's rotation or see the planet's rotation as we go about our daily lives. So are there ways to verify its return from the ground? And is it possible to watch the rotation of our planet from somewhere in space? Today, we will look for answers to this question with you. First of all, to give a simple answer to the question, seeing the Earth's rotation depends on where you look. When we consider the real-time rotation of the Earth, it is not possible to watch it in motion because it only makes one revolution every 24 hours. As you can imagine, this situation is too slow for our helpless human eyes to perceive. Yes, sorry, it is impossible to watch the Earth's rotation. But don't lose hope right away. There are other ways we can prove the rotation of our planet without ever leaving the Earth. For example, by observing the positions of other objects in the sky. The easiest way to observe the Earth's rotation is to watch the apparent motion of celestial bodies. Stephen Merkowitz, a scientist and project manager at NASA's Goddard Space Flight Center in Maryland, told Live Science in an email. This motion is most noticeable when the celestial body is close to the horizon and you can see parts of the Earth as a reference. Merkowitz said one of the easiest ways to see the Earth in action is to watch the sunset. When you watch the sunset, your position on Earth gradually moves away from the sun, so it looks like the sun is setting towards the horizon. Another way to see this effect is to observe the moon and stars at night as long as there is a reference point as the horizon does not move. Objects glowing far above will appear to be in motion as the Earth rotates. The rotation of our planet can also be observed with a Foucault pendulum. Physicist Jean Foucault exhibited this experiment at the World's Fair in Paris in 1851, and it was the first official experiment to prove that our planet rotates according to the Smithsonian Institution. Freestanding pendulums usually keep swinging in the same direction. Only a push or pull in another direction can change that. Foucault realized that as the Earth rotates under the pendulum will gradually change angles as it swings. But Earth's rotation is so slow that it takes about 15 minutes for a change in the pendulum's oscillation to become visible. The moon and tides. According to Merkowitz's explanation, the Earth rotates because it is made up of clumps of dust and gas that are already spinning and are pulled together by gravity. After piling up on our planet, they never stopped moving. There is no friction in space to slow down motion. The tides are more evidence that the Earth rotates. The tide occurs at a particular position in the Moon's orbit where it is closest to Earth. As the Earth rotates, it brings this position toward the closest point in the Moon's orbit. Closer to the Moon means closer to its gravitational pull. The Moon's gravity pulls on the oceans and creates tides, temporarily causing the oceans to swell outward toward the Moon. However, this is a temporary situation. As the Earth rotates, the water level drops until it reaches the farthest possible distance from the orbiting Moon or at low tide. This cycle continues iteratively. The hourly variation in tides is mostly due to Earth's rotation, Merkowitz said. The daily variation in tidal time at a given location is due to the Moon's orbit. So, maybe we can't watch the Earth's rotation, but we can see some of the effects of its rotation. Watching the tide rise or the sun set is also an easy way to witness a cosmic phenomenon. That's all from us for today. Don't forget to like our video and subscribe to our channel. See you in another video. Bye-bye. Hello, everyone. How large the universe is a fact known to everyone, and it is selfish to think that there will be no other life forms in such a large universe. Although scientists have not been able to provide convincing evidence so far, most scientists think that the possibility of intelligent extraterrestrial life forms is high. As Cosmic Garden, today we will examine the possible existence of our neighbors in the backyard of our universe. When we examine the sky on a clear night, we realize how small we actually are. However, this awareness is not limited to the feeling of smallness. Knowing that we are a blue dot with the most suitable conditions for life among dozens of planets inside and outside our solar system brings a strong sense of loneliness along with the feeling of smallness. Considering that the width of the universe is 93 billion light years, it brings fear along with the feeling of loneliness. There's no guarantee that we won't be pulled up by a huge beam of light suddenly one night, but they're also pretty hesitant to show up. So far, we have yet to find evidence of possible advanced civilizations. Well, they are not too eager to contact us. According to NASA's 2022 statement, the number of planets discovered has exceeded 5,000. These are not just numbers. Each one is a new world. Of course, we can't go and see what kind of technology these worlds have, but scientists have been using the Drake equation for years to study the number of intelligent civilizations in the Milky Way galaxy. Now, Adam Frank of the University of Rochester and Woody Sullivan of the University of Washington take a slightly different approach to the problem. They propose a change to his equation. Instead of estimating how many civilizations can be contacted today, they estimate how many civilizations have existed since the beginning of the universe. Before going into the details of this subject, let's explain the Drake equation for you. This equation is made up of 7 equations multiplied by each other, and each term is a subproblem that you have to answer in order to understand how many civilizations are out there. This equation is briefly as follows. The number of civilizations we can hope to communicate with is equal. The amount of star formation, how many of the formed stars have planets, the average number of planets suitable for habitation, the number of planets among these planets in which environment suitable for life is formed in any way, how many of these planets have intelligent life, how many of these planets can send signals indicating their existence in space, and the detectability of this signal time. The Drake equation looks pretty simple, but it's pretty annoying due to 3 big unknowns. We know approximately how many stars exist, but we don't know how many of these stars have potentially life-bearing planets, how often life has evolved to give rise to intelligent beings, and how long any civilization would last before it perished. Based on research and recent exoplanet discoveries, it is assumed that 1/5 of all stars have habitable planets orbiting them. This leads them to the conclusion that there must be advanced technological civilizations out there somewhere else. Now we can easily eliminate one of the three great uncertainties. The question of how long civilizations can survive is still a great mystery. Frank and his co-author, Woodruff Sullivan, simply expanded the question and asked, are we the only technological species that has ever emerged? Frank and Sullivan then calculated the line between a universe in which humanity was the only civilization experiment and a universe in which others came before us. Of course, we have no idea how likely it is for an intelligent and technological species to evolve on a given habitable planet, but we do know exactly how low the probability must be for us to be the only civilization produced by the universe. Frank and Sullivan call this a line of pessimism. If the actual probability is greater than the pessimistic line, then a technological species and civilization has probably already occurred. When researchers using this approach calculated how likely advanced life was among the 10 billion trillion stars in the universe, they found that the result was 1 in 10 billion trillion. This means that even if there are thousands of civilizations in our galaxy, if they only lived as long as we did, they're probably all extinct long ago, and others won't evolve until we're gone. The fact that our possible galactic neighbors have already vanished, we know, is troubling. However, when we consider the interstellar distance and the constant speed of light, we may never meet with possible civilization. Let's say we are shopping from a civilization 20,000 light years away. Cargo sent this far would take 40,000 years to travel back and forth. How about a great method to leave a legacy for future generations? Today, there are many scientific projects devoted to the search for life beyond Earth. From biomolecular detection to exoplanet atmospheres, biomarker detection, and potentially habitable planets and moons of the solar system. However, when it comes to detecting traces of other intelligent or technological civilizations, there is a lot of speculation about what these traces might be. We are sure that finding a spacecraft with which we can follow interstellar objects in the solar system would change the balance. But such a spacecraft must be able to maneuver at any moment and increase its speed. We can say that such a spacecraft will take some time with the technology we currently have. This is the idea behind the concept project, which scientists called the Extrasolar Interceptor and Sample Return Spacecraft at the launch of James Webb, which was launched in 2021. The launch of this vehicle will be able to catch up with an extrasolar object, collect a sample, and return to Earth within a 10-year time frame. In this way, our view of the universe and our place in the universe will completely change. The James Webb Space Telescope can detect coherent passive technosignals, according to a new paper published in the Planetary Science Journal. Atmospheric pollution is the industry's unique waste that does not originate from other forms of biology on Earth. So, finding such pollution in the atmosphere of an exoplanet would be convincing proof that the planet has the technology. As a result, our universe is 13.8 billion years old, and most stars formed before our solar system, For a possible civilization to have technology that we are incapable of understanding, it only needs to be older than we are. As Arthur C. Clarke said, there are two possibilities. Either we are alone in the universe, or we are not alone in the universe. Both possibilities are equally frightening. That's it for now. Do you think we are alone in the universe? Thanks to the projects developed, will our search for extraterrestrial intelligent life yield results in the coming years? Please share your thoughts with us in the comments. And don't forget to subscribe to our channel and turn on the bell for more videos. See you soon. Hello, everyone. When we think of the Big Bang, we think of a loud, hot, bright explosion. But was the explosion followed by a colder, darker shadow? In the standard cosmological picture, the early universe was a very exotic place. Perhaps the most important thing that happened in the cosmos was the Big Bang's inflation event, which took place very, very early, causing our infinitely large universe to enter a period of expansion in very, very minute fractions of a second. When inflation ended, the exotic quantum fields that caused this event decayed into the torrent of particles and radiation that remains today. When our universe was less than 20 minutes old, these particles began to assemble themselves as the first protons and neutrons during what we call the Big Bang nucleosynthesis. Big Bang nucleosynthesis is a pillar of modern cosmology, as the calculations behind it accurately predict the amount of hydrogen and helium in the cosmos. However, despite the success of our early universe picture, we still do not understand dark matter, the mysterious and invisible form of matter that makes up most of the mass in the cosmos. 5/6 of the universe seems to be made up of a mysterious substance called dark matter. Until now, physicists assumed that dark matter was formed by the same burst of heat that started the universe. But dark matter lives in a kind of parallel, shadow world, and hardly interacts with normal matter, which makes up everything we can see, feel, and observe. Despite the success of our early universe picture, we still do not understand dark matter, the mysterious and invisible form of matter that makes up most of the mass in the cosmos. The standard assumption in Big Bang models is that the process that created particles and radiation also created dark matter, and after that, dark matter lurked around, ignoring everyone else. But a group of researchers came up with a new idea. They argue that our periods of inflation and Big Bang nucleosynthesis are not alone. Perhaps some kind of shadow was created with the Big Bang, days after the universe began. This is what Austin physicists Catherine Fries and Martin Winkler propose in a new theory they call the dark Big Bang. It could explain why dark matter has eluded detection until now, and how scientists can finally change that. This is what Austin physicists Catherine Fries and Martin Winkler propose in a new theory they call the dark Big Bang. It could explain why dark matter has eluded detection until now, and how scientists can finally change that. There are two big explosions in our scenario, Winkler said of the outcome, which came out in the preprint last month. The hot Big Bang creates hot plasma of visible matter and radiation, as in the standard picture. Dark matter is created by a later, darker Big Bang. In the Big Bang story, we're all familiar with regular matter, like atoms was created in the early universe, when space was hot and crowded. As the universe cooled and expanded, atoms began to combine into structures like galaxies and stars. This is where dark matter came into existence. We know that dark matter exists because nothing else can provide enough gravity to keep stars inside galaxies, at least if our understanding of gravity isn't somehow wrong. Dark matter has been playing this critical role since just after the Big Bang. Like a kind of cosmic usher, dark matter gravitationally directed atoms into place. Dark matter has decided where today's galaxies will sit, and to date every galaxy, including ours, has been held together by a cloud of these invisible particles. So where did dark matter come from? Most theories say it formed in the same Big Bang as everything else, but Winkler and Fries began to question that assumption. It's often forgotten that we have zero evidence for dark matter before times related to structure formation, Winkler said. So maybe dark matter wasn't around yet when normal matter was formed. In fact, we found that dark matter formation may have taken place as long as a month later, he said, almost an eternity by cosmological standards. It's a crazy new theory with important implications for scientists trying to measure dark matter. If the dark Big Bang had really taken place, the effects of its seismic explosion would still ripple through the universe today. When massive objects undergo dramatic changes, they can produce gravitational waves that cause space to shake like the surface of a pond with a stone thrown into it. In 2017, an experiment called LIGO won the Nobel Prize in Physics for measuring the gravitational waves produced by two colliding black holes. However, the gravitational waves produced by the dark Big Bang will be weak and slow-moving waves for LIGO to detect. Instead, the authors suggest looking at the effect of gravitational waves on distant flashing stars called pulsars. Pulsars are dead rotating stars that send light to Earth at regular intervals like a lighthouse. These periodic beams of light must be affected as gravitational waves travel through the universe. According to Fries and Winkler, future studies combining information from many of these rays, such as the International Pulsar Timing Array and the Square Kilometer Array, may find conclusive evidence of the dark Big Bang. The new idea emerged at a critical moment when physicists' search for dark matter was approaching a breaking point. What makes dark matter so mysterious is that it seems to pass through normal matter. Scientists have built giant underground detectors to catch dark matter particles as they pass through Earth, but elusive ghosts don't seem to leave any traces. Physicists began to fear that only gravity connected the dark world to ours, and that this tiny pull was too small to be measured in a laboratory. But the new theory addresses this frightening possibility. Once we allow the idea of purely gravitational dark matter, the dark Big Bang is perhaps the most plausible production mechanism for dark matter, Winkler said. The good news in our article is that even if dark matter only gravitationally couples, there are still great chances to test such a scenario. Indeed, the coming years may reveal the aftershocks of the dark Big Bang and finally fill this huge gap in our knowledge of the cosmos. That's all from us for today. What do you think about this discovery? Please share your thoughts with us in the comments section. To follow the news from Cosmos, don't forget to subscribe to our channel and like the video. See you in another video. Hello, everyone. Scientists have recorded the most powerful cosmic explosion ever. It was a gamma-ray burst that occurred 2 billion light-years from Earth. The gamma-ray burst was so powerful that it impacted our atmosphere 20 billion trillion km away and could be seen with amateur telescopes. So what are these gamma-ray bursts? What is the phenomenon that creates these enormous cosmic explosions? Finally, And most importantly, why was this record-breaking gamma ray burst so important to astronomers? In recent years, light from a very energetic gamma ray burst has reached our planet. This light began its journey when the universe was only 900 years old and traveled more than 12.8 billion years to reach Earth. The burst of light was first detected by instruments aboard the Earth, orbiting Neil Gehrels Swift Observatory and Conus Wind, a grube-hunting telescope operating in interplanetary space. A gamma-ray burst, or GIUB as the name suggests, is an intense gamma-ray burst. It usually lasts less than a second, and in that time, it emits as much energy as the Sun in its 12 billion-year lifetime. So what is the source of this enormous energy? To understand this, let's take a quick look at gamma rays. These are the most energetic electromagnetic waves, or the highest energy form of light. A single gamma ray photon can be 1,000,000 times more powerful than a visible light photon. These photons are packed with so much energy that they are a type of ionizing radiation, meaning they can strip an atom of its electrons. Thus, they can cause ionizations that can damage our tissues and DNA. Fortunately, the ozone layer on Earth protects us from such radiations, and it filters them out before they harm us. But if these powerful photons can't reach the surface, how were gamma ray bursts detected in the first place? Reply: the Cold War. In the 1960s, the United States launched Vela satellites to detect pulses of gamma radiation emitted from nuclear weapons tested in space. On July 2, 1967, the Vela 4 and Vela 3 satellites detected a flash of gamma radiation, unlike any known trace of nuclear weapons. Further analysis ruled out that these mysterious eruptions could have been terrestrial or even solar origin. 6 years later, the first paper on gamma-ray bursts and their cosmic origin was published. This mission, which started with a small budget, tried to detect nuclear explosions in space and was extremely successful and costly after 26 years. More than 1,700 grubes have been observed so far. But it took decades to better understand what they are and why they're so powerful. Another challenge is that the light curves from each GIUB are different. This complicates understanding them as a group. However, in general, they can be classified as short and long GIUBs. Short bursts typically last a few seconds. They come from two super-dense neutron stars packed in a binary system. Over millions of years, their orbits are disrupted by energy lost by gravitational waves. When they get close enough to touch each other, they form a black hole with a violent burst of energy. Longer bursts last a few minutes and come from massive stars that explode at the end of their lives, again forming black holes. Twin rays formed around a rotating disk of material that was not immediately swallowed by the black hole. They radiate into space with intense energy, one going up and the other down, looking away from the disk. These travel inside the dying star and erupt outward, while the rest of the star explodes as a very powerful supernova. The power of gamma ray bursts comes from their tight focusing. These thin rays concentrate explosive energy in a very narrow direction. If the beam is directed toward Earth, astronomers can see a gamma ray flare bright enough to be detected billions of light years. Out of the way, a typical supernova is observed. The record-breaking supernova recently was named GIUB 200-221,009A, the first gamma-ray burst observed on October 9, 2022. Located 2.4 billion light-years from Earth in the direction of the Sagitta constellation, GRB 221,009e is thought to have formed as a result of a massive star reaching the end of its life and turning into a supernova. GRBs like this are often associated with stellar collapse, and this process also triggers a massive cosmic explosion, a supernova. This violent and powerful explosion should have left behind a neutron star or a black hole. However, at this time, scientists have not yet been able to confirm the origin of GRB 220,009e. Based on the enormous energy released and the long duration of the eruption, GRB 221,009e is probably 30% higher than our Sun. Brendan O'Connor, an observational astronomer at the University of Maryland, George Washington, who led another team to detect GRB, told Live Science. It was caused by the collapse of a massive star with a mass of evidence of massive stellar explosion requires detection of a supernova following the GRB. We are currently looking for this supernova and using the Gemini Observatory to find the first evidence. GRB 220,009e is so bright that it will take months to become too dim to see with telescopes, so astronomers have time to study it. Even amateur astronomers are moving to observe the GRB, Rastinjad said, but further work will soon have to pause. This will not be the only mystery astronomers aim to solve using GRB 221,009e. Observing this G-bar in more detail could help determine where the heavy elements of the universe were created. That's all for today. Don't forget to like the video and subscribe to our channel for more such content. See you in the next video. Bye-bye. Hello, everyone. The planet Mars, which has been a favorite of science fiction movies many years ago with its red soil and Earth-like conditions, and which appears as a way out in case of possible apocalypse, continues to be a favorite of most scientists for a long time. Although it has an important place among the interests of astrobiology circles due to its proximity and similarity to Earth, there is no conclusive evidence of life on Mars so far. So how well do we know this red planet? Why do we love this little planet so much when it's not so flashy? Why has Mars been so cherished since ancient times? And why is Mars the only planet other than Earth that we have been driving around in our era? Mars, which has symbolized many things throughout history. He started his journey as the god of war and slaughter because of his red color. For many years, people looked at this planet and made offerings. It wasn't because of the distinctive coppery blood that made it a red planet, but because of the high levels of iron oxide or rust found in its soil. Sometimes, when people raised their heads to the sky, they feared invasions from there. In H.G. Wells' War of the Worlds, he portrayed Martians as bloodthirsty invaders. The science fiction literature and cinema of the 20th century further reinforced the special position of Mars in the eyes of people. We may no longer be able to tell fantastic stories about high-tech aliens living on Mars. Science may have cast aside our baseless excitement, but it also offers us a brand new excitement about us. The future that humanity will establish on Mars, the first baby to be born there. We are witnessing the beginning of a brand new era. The vehicles we've sent to the red planet since the mid-20th century have given us a lot of information about Mars. We learned about its atmosphere, climate, soil structure, and much more. But what we really wanted to know was whether there was life out there. We have to admit that Mars looks very similar to Earth at first glance. It has mountains, volcanoes, canyons, wide plains, polar ice caps, a thin atmosphere, and occasionally cloudy skies. But when you examine it in detail, you immediately find its differences from the Earth. Of Mars, it lacks surface water resources, a thick atmosphere, magnetic field, and plate tectonics. So it currently does not have advanced life forms. Also, the craters formed by the collisions are few on Earth, but many more on Mars. No matter how familiar the landforms may seem, its reddish color is further proof that Mars is no place like Earth. In fact, Mars is quite different from Earth. Since its orbit is in the form of a flattened ellipse, its distance from the Sun varies more than the Earth. Its closest point to the Sun is 206 million kilometers. The farthest point is 248 million kilometers. There is a difference of 42 million kilometers between them. In the world, this number is 5 million kilometers. One orbit of Mars around the Sun takes 687 Earth days, or about 1.88 Earth years. Although they are not similar to the world in this regard, one day is quite similar. Compared to Earth day, Mars day length is 24 hours 37 minutes. Since its mass is low, its gravitational force is also lower than Earth's. The gravity of Mars is 0.37 times that of Earth. In other words, a person weighing 80 kg on Earth would feel as if he weighed 30 kg on Mars. Even if our mass did not change, our weight would change in newtons. Phobos and Deimos. In the moons of Mars, which has 2 moons in its name, Phobos means fear and Deimos means terror. It was discovered by the American astronomer Asaph Hall in August 1877. Despite the weight of their names, we can only see these 2 moons through very powerful telescopes because they are actually quite small, with Phobos 22.2 kilometers in diameter and Deimos only 12.6 kilometers in diameter. These moons, on the other hand, constitute a geological mystery in their own right. One possibility is that they may have been asteroids orbiting Mars in the distant past, gravitating towards it. Recently, however, there has been evidence to support the idea that they may have been ripped off from Mars by a very violent impact. For a long time, the possibility of water on Mars was a mystery. Due to Mars' low gravity and lack of magnetic field, the atmosphere was blown away into space billions of years ago. Thus, temperatures and atmospheric pressure fell below the level at which liquid water could exist. What remains of Mars' waters is trapped in polar ice caps and ice beds beneath the dusty surface. The main feature of Mars that makes it a special planet for scientists is that its surface is very similar to the Earth's surface. The area of Mars is as much as the sum of the land on Earth. About 150 million kilometers to the surface of Mars, which has had no precipitation for hundreds of millions, perhaps billions of years, is drier than the driest desert on Earth. However, the valleys once formed by the stream still remain on its surface. In addition to these valleys, there are many other surface forms that we are accustomed to seeing on Earth, such as volcanoes, plains, craters, dried lake floors. This suggests that liquid water existed in the past, as well as layered sedimentary rocks. The northern hemisphere of the planet is several kilometers lower than the southern hemisphere. This suggests that there may have been an ocean that once covered most of the northern hemisphere. The crust of Mars is about 35 kilometers thick in the northern hemisphere and 80 kilometers thick in the southern hemisphere. However, this crust is not in a fractured structure consisting of plates like on Earth. It is one piece and does not move. Beneath the crust, it is estimated that there is a mantle layer that is less hot, thicker, and inert than Earth's. Magnetized rocks in some of the oldest parts of the Martian crust show that Mars had a core of molten iron some 4 billion years ago, which produced a magnetic field. Unfortunately, both are not available at the moment. As the core cooled, the dynamo stopped, and Mars lost its strong magnetic field. In other words, just like on the Moon, the compass is useless to find direction on Mars. Navigation isn't the only problem with the disappearance of the magnetic field. Mars probably originally had a warm, moist, and thick atmosphere of carbon dioxide, but that changed as the magnetic field disappeared. Charged particles from the Sun must have melted Mars' thick atmosphere as they reached the planet directly. This means that an ozone layer, like the one on Earth, cannot develop and negatively affects possible life. The seasons on Mars are quite different from those on Earth. We said that Mars has an axial tilt very similar to that on Earth. Yes, this causes seasons like on Earth, but when we look at Mars, we see that its orbit is more elliptical than Earth's nearly circular orbit. The combination of the tilt of the planetary axis and the drastic change in its distance from the Sun throughout the year on Mars creates sharp seasonal transitions unlike anything on Earth. During the winter, more than a quarter of the planet's atmosphere freezes to solidify. In the summer period, the sandstorms created by the increasing temperature level are harsh, as if they are going to swallow the whole planet. On a cold winter night on Mars, the temperature can drop to -150°C, while on a warm midsummer day, it can rise to about 35°C at the equator. But don't get too excited about sunbathing. Friends, it is generally a rather cold planet than Earth, as the average temperature is -60°C. Also, considering the deadly radiation from the Sun, this is not the place to vacation. But it still doesn't mean we can't establish a colony. Mars was first recorded 4,000 years ago. Galileo was the first to see the red planet through a telescope in 1610. We knew almost nothing about it until the 19th century. But in 1877, when our telescopes were good enough to show the features of the planet, an Italian astronomer named Giovanni Schiaparelli made the first map of Mars. There were dense linear structures on its surface. These canals were long seen as the work of the advanced civilizations that lived there. However, as technology developed in the following years, it was realized that these channels were actually a kind of optical illusion caused by old telescopes. So far, many spacecraft have been sent to Mars from India, the United Arab Emirates, and China, especially the United States, the European Space Agency, and Russia. Although some of the missions, most of which were unsuccessful, reached Mars, they were terminated after a short time because they lost contact with the Earth. Mariner 4. The probe, sent by NASA in November 1964, was the first mission to reach Mars and sent us the first close-up pictures of the red planet's surface. Viking 1 and Viking 2. The Viking 1 and Viking 2 spacecraft were launched by NASA in 1975. Both consisted of an orbiter and a rover. This mission is the first successful U.S. Mars mission to land on the surface. The vehicles were landed in 2 different regions on Mars. They were sent to get to know the red planet better and search for traces of life. They found no signs of life, but they found all the essential elements needed for life, such as carbon, nitrogen, hydrogen, oxygen, and phosphorus. Scientists think that the sun's ultraviolet radiation and excessive dryness of the soil prevent the formation of living organisms. That's why we have to look for living life much deeper under the ground. Viking orbiter and lander vehicles have served much longer than their design life, thanks to their radioisotope thermoelectric generators Mars 2 and Mars 3. After years of unsuccessful attempts by the Soviet Union, the Mars 2 orbiter, which was finally launched in 1971, successfully reached Mars, but as the landing module entered the atmosphere at a steeper angle than planned, the landing system malfunctioned and the vehicle crashed to the surface. The Mars 3 rover, on the other hand, was able to maintain its mission on the surface for only a few seconds, although it successfully landed on the surface. Although the desired success has not been achieved in surface vehicles, orbital vehicles, they obtained important data on the Martian atmosphere, surface temperature, and pressure, and sent 60 photos to Earth. Mars Pathfinder and Sojourner rover. The vehicle, which was sent in December 1996, broke new ground with its innovative design. It was the first soft landing on Mars with airbags and the first wheeled vehicle to be used on any planet in the solar system. Sojourner, who we can define as the father of the rovers, did research for 83 days, exceeding his one-week tenure. Spirit and Opportunity. Twin rovers landed on Mars in 2004. They studied the chemical and mineral makeup of the soil. They eroded the rocks with their special tools and obtained unique information. The data showed that Mars once had a watery past. Spirit and Opportunity have found the first evidence of the red planet's wet past that may have been home to microbial life. Curiosity. The Curiosity rover, launched in 2011, is one of the largest and heaviest vehicles ever to land on the Martian surface. It has landed in Gale Crater, where it searches for traces of microbial life that Mars may have once hosted. It is no accident that Gale Crater was chosen for research. As with other landing points, after months of examination and elimination, regions where the most productive results can be obtained and which used to be home to rivers and lakes are selected. The minerals and debris that may have accumulated on the shoreline of this crater may be the greatest evidence for life. Curiosity rover's research is still ongoing. According to a report published in June of 2020, it has solved the mystery of methane on the red planet. Curiosity had detected methane gas on Mars. This is really exciting because most of the methane gas on Earth is produced by microbes. Likewise, methane gas on Mars may be the greatest evidence of microbial life, but we also know that methane does not have to be produced by a biological process. It can also be produced as a result of geological processes. The confusion experienced by scientists after this exciting news was that the European Space Agency's ESA, ExoMars Trace Gas Orbiter vehicle, did not encounter methane in the high parts of the atmosphere. As a result of the measurements made separately during the day and night, it was determined that the methane concentration in the Gale Crater changed during the day. Still, research continues on why methane is still not found in the high atmospheres globally. Perseverance. Most of us have followed closely the Mars 2020 mission. You may have at least sent your name to Mars. The spacecraft, which was sent in July 2020, landed on the Martian surface in February 2021. He continues his research in Jezero Crater, collecting rock and sediment samples. As we mentioned before, the landing points of the surface vehicles are meticulously selected. The Jezero Crater was chosen because once, 3.5 billion years ago, there was a large lake here from which river channels flowed. clay and carbonate minerals found on the shoreline of this lake, which need water for its formation. It has properties that can protect microbial living residues. Salda Lake, where tests and experiments were carried out before Perseverance was sent to Mars, has a similar geological structure. Salda Lake is a unique boon for understanding how the biosignatures preserved in the region will appear to Perseverance. In addition to all the important data obtained, NASA has achieved another first by airing a helicopter, Ingenuity, on an extraterrestrial planet for the first time. This was an experimental mission and was carried out to test the first powered flight on Mars. Zhurong. The second country to successfully land on Mars was China. It lost contact with the Soviet Union probe shortly after landing. The vehicle, which was sent with the Tianwen-1 Mars mission in July 2020, will conduct research on the atmosphere and geology of the planet. The fact that our interest in the red planet has become more concrete in recent years has opened new doors for us to discover. Even in a difficult process like the pandemic, the successful missions of 3 different countries to Mars are the biggest proof of this love and interest. Every new Mars journey is a first, and it's really exciting. Perhaps the fossils we will encounter there one day may be very different from what we know and expect. In fact, a molecule or biological process that we have never encountered before is discovered, and this may bring many new discoveries. While dreaming of settling on a different planet, maybe even a type of virus that can bring the end of humanity may be encountered. However, it's still definitely worth a try. What do you think about this subject? Please do not forget to share your ideas with us in the comments section. If you don't forget to subscribe to the channel and turn on notifications, you can be notified of new videos within seconds. See you in the next video. Welcome to our space documentary channel, where we dive into the amazing world of pulsars, the cosmic lighthouses of the universe. In this episode, we'll explore the captivating secrets behind these mysterious objects and their mesmerizing pulses. Join us as we unravel the mind-boggling science of pulsars in a way that's accessible and engaging for everyone. Pulsars are incredibly dense and fast, spinning neutron stars, which emit beams of radiation into space. These celestial powerhouses were first discovered back in 1967 by Jocelyn Bell Burnell and Anthony Hewish, and their findings revolutionized our understanding of the cosmos, earning them the Nobel Prize in Physics. These extraordinary objects are formed from the remnants of massive stars that exploded in dramatic supernova events. When a star runs out of fuel, its core collapses under intense gravity, giving birth to a neutron star. These neutron stars are mind-bogglingly dense, packing more mass than our sun into a space no bigger than a city. The intense gravitational forces cause the neutron star to spin rapidly, often hundreds of times per second. As it spins, it shoots out beams of radiation from its magnetic poles. If these beams happen to align with Earth, we observe regular pulses of radiation, similar to a cosmic lighthouse sweeping across the sky. What's truly mind-blowing is the precision of these pulses. Pulsars are like the most accurate clocks in the universe, with some pulsars flashing on and off in mere milliseconds. Their pulses are so precise that even the tiniest variations can offer profound insights into the nature of space-time and the behavior of matter under extreme conditions. But it doesn't stop there. Pulsars boast insanely strong magnetic fields, trillions of times more powerful than Earth's magnetic field. These magnetic fields generate intense beams of radiation that shoot out from the poles, giving rise to the pulsating effect we observe. Pulsars also experience something called glitches. These sudden increases in rotation speed cause disruptions in their pulse patterns. Scientists believe that these glitches occur when angular momentum is transferred from the pulsar's superfluid core to its outer crust. Studying these glitches provides valuable clues about the nature of matter under extreme conditions. Aside from their scientific significance, pulsars have practical applications too. Their precise pulses can be used as navigational aids for spacecraft, just like lighthouses guide ships. By measuring the arrival times of the pulses, astronomers can determine the position and motion of spacecraft with incredible accuracy. Pulsars have also played a crucial role in testing Einstein's theory of general relativity. The observation of pulsar binaries, where two neutron stars orbit each other, has provided evidence for the existence of gravitational waves, the ripples in spacetime predicted by Einstein. Pulsars continue to capture the imagination of scientists and enthusiasts worldwide. Their exotic nature and fascinating physics challenge our understanding of the universe and push the boundaries of what we thought was possible. With advancing technology and the launch of new telescopes, we're on the verge of uncovering even more about these cosmic beacons and the secrets they hold. In summary, pulsars are like cosmic lighthouses, shining a light on the mysteries of space with their precise pulses. These remnants of massive stars provide valuable insights into matter, extreme environments, and the laws of physics. As we venture further into the cosmos, pulsars will remain key players in our quest for knowledge, guiding us on an awe-inspiring journey of discovery. Stay tuned for more thrilling episodes as we unravel the wonders of the universe and reveal the hidden marvels that await us. As we delve deeper into the mesmerizing wonders of the cosmos, we encounter one of the most intriguing phenomena in the universe: pulsars. These celestial marvels, often referred to as the lighthouses of the universe, captivate our imagination with their mysterious pulses of light. In this episode, we embark on a journey to explore the secrets of pulsars, shedding light on their enigmatic nature in a way that's accessible and captivating for all. Pulsars are the remnants of massive stars that have undergone a supernova explosion, leaving behind a compact and incredibly dense core known as a neutron star. These stellar remnants pack an astonishing amount of mass into a relatively small space, creating an environment of extreme density and gravity. What sets pulsars apart is their rapid rotation, spinning at incredibly high speeds. As these neutron stars rotate, they emit beams of electromagnetic radiation from their magnetic poles. These beams sweep across space much like the beam of light from a lighthouse. If Earth happens to be in the path of these beams, we observe a regular series of pulses, hence the name pulsars. The precision of these pulses is nothing short of astounding. Some pulsars emit pulses with a remarkable regularity, resembling the ticking of an incredibly accurate cosmic clock. These pulses can occur at intervals ranging from milliseconds to several seconds, with some of the fastest pulsars spinning hundreds of times per second. The source of this incredible precision lies in the pulsar's strong magnetic field. Pulsars possess magnetic fields trillions of times more powerful than Earth's magnetic field. These intense magnetic fields play a crucial role in shaping the beams of radiation emitted by the pulsar, allowing us to observe their pulsating nature. The study of pulsars has not only provided us with a deeper understanding of the universe, but has also yielded practical applications. The precise and consistent nature of pulsar pulses has made them invaluable tools for spacecraft navigation. By carefully measuring the arrival times of these pulses, scientists can accurately determine the position and velocity of spacecraft in the vastness of space. Moreover, pulsars have contributed significantly to our understanding of the fundamental laws of physics. The study of pulsar binaries, where two neutron stars orbit each other, has allowed us to test Einstein's theory of general relativity. Observations of these binary systems have provided evidence for the existence of gravitational waves, confirming one of the most profound predictions of Einstein's theory. But the fascination with pulsars goes beyond their scientific importance. They ignite our curiosity and inspire a sense of wonder about the mysteries of the universe. Their mesmerizing pulses, reminiscent of cosmic beacons, remind us of the vastness and complexity of the cosmos. They serve as a reminder that there is still much we have yet to discover and understand. As technology advances and our understanding of the universe deepens, we continue to explore the depths of pulsar research. New telescopes and advanced detection methods allow us to uncover more about these enigmatic objects and the extraordinary physics that govern their behavior. In conclusion, pulsars stand as celestial lighthouses, beacons of cosmic wonder, and gateways to unraveling the mysteries of the universe. Their precise pulses and profound implications have fascinated scientists and stargazers alike. As we venture further into the cosmos, pulsars will guide us, shedding light on the intricacies of space and time and inspiring us to explore the unknown. Join us in the next episode as we continue our cosmic odyssey, peering into the depths of the universe and uncovering its hidden treasures. Stay tuned for more captivating space documentaries that ignite the spark of curiosity within us all. What would you like the next topic to be about? Please specify in the comments. Don't forget to subscribe to the channel and turn on the bell notification. See you in another video. Hello, everyone. According to research, there are around 40 quintillion star-forming black holes lurking in the dark places of space. In order to fully understand the magnitude of this number, let's show it with a number. Yes, isn't it enormous? Fortunately, we are a safe distance away from this and many other stellar black holes. There is no need to worry about this for now. How many black holes do you think are in our Milky Way galaxy, which is home to our home? Assuming that our galaxy reached its present size about 5 billion years ago, we can calculate that the number of stars that have turned into black holes in the last 5 billion years is around 10 billion. In other words, there are at least 10 billion black holes floating around in our galaxy, the Milky Way. Things just got more frightening now, right? But what if we suddenly became a black hole's luncheon? Let's examine the answer to this question together. Black holes are the most compact celestial bodies known, formed by stars much more massive than our sun collapsing into themselves or by a supernova explosion. In short, black holes are born from the death of star. Black holes formed by a star collapsing or exploding are called stellar black holes and are quite common in the universe. These black holes, which are about 16 km in diameter, also have a rival and are called supermassive black holes. These have roughly the diameter of our solar system and more mass than 1 million suns combined. Due to its dense mass and extreme gravitational force, it could have destroyed not only Mercury, but also us. Good luck to the fog after this point. When the black hole gets close enough to the Earth, the side closest to it will begin to stretch towards the black hole first, vacuuming our atmosphere. And then the inevitable end will happen and the Earth will shatter. Depending on what your definition of luck is, if the Earth manages to fall into the orbit of the black hole, we will experience tidal warmth. The strong and unstable gravity on Earth will constantly deform the planet. This massive amount of internal friction will heat the Earth's core to incredible proportions, which will likely cause earthquakes. It will cause volcano eruptions and tsunamis. Means that there will be a 1 trillion times difference between your head and your toe. This force is the tidal force that happens to our world. As you continue to stretch out to your atoms, your body will form elongated like a spaghetti. The tragedy you experience is what scientists call spaghettification. This event can occur several hundred kilometers from the event horizon for an average-sized stellar black hole. But if you start falling into a supermassive black hole, you will reach the event horizon much further from the central gravitational source. In short, congratulations. If you fall into a supermassive black hole, you will painlessly cross the event horizon without getting the consistency of a long, thin noodle. Now you know which black hole to choose if you have to choose between black hole. When faced with a stellar black hole, everything you can think of, including our solar system, is bound to pass through the event horizon and shatter down to its atoms. On the other hand, when we come face to face with a black hole, that delicate balance of our solar system is disturbed and the planets start colliding with each other. The asteroid belt between Mars and Jupiter begins to pull towards us, which means another disaster scenario. Of the 552,894 known asteroids in the asteroid belt, about 200 of them, even one of these asteroids more than 100 kilometers wide, were to hit us, we would be dead without the consistency of spaghetti. Frankly, we're not sure which fate would be worse. All the matter in our solar system joins the accretion disk around the black hole. As matter is drawn into the black hole, it produces large amounts of radiation. So even if we got rid of all the asteroids somehow, we'd probably be dead from radiation. Worse still, we could eventually be thrown out of orbit or swallowed by the sun or the black hole. We're sorry, but we don't have a win in these scenarios. But maybe one day we can find a way to protect ourselves with a hyper-powered space shuttle. And if we manage to pass through the event horizon safely, we could end up in an area where the laws of physics have completely collapsed. Gravity, the speed of light, and even the way atoms attach and react, things like that, can be completely different. Who knows? Maybe we'll find ourselves in our daughter's bedroom or get a chance to see a wormhole. It's kind of sad that we'll never find out. That's all from us for now. What do you think is beyond the black hole? Please share your ideas with us in the comments section. Don't forget to like our video and subscribe to our channel for more such content. See you in the next video. Hello, everyone. Astronomers led by the University of Warwick have identified the oldest star accumulating debris from orbiting planetoids in our galaxy, making it one of the oldest rocky and icy planetary systems discovered in the Milky Way. The researchers, whose findings were published in the monthly notices of the Royal Astronomical Society, concluded that the remains of a faint white dwarf located 90 light-years from Earth and its orbiting planetary system are more than 10 billion years old. Most stars, including those like our Sun, are destined to become white dwarfs. A white dwarf is a star that has burned all its fuel, has shed its outer layers, is undergoing a process of contraction and cooling. During this process, the orbiting planets will, of course, decay and in some cases disappear, leaving the debris of these planets to accumulate on the surface of the star. For this study, the University of Warwick-led team of astronomers modeled two unusual white dwarfs detected by the European Space Agency's Space Observatory Gaia. Both stars have been contaminated by planetary debris, one unusually blue and the other the faintest and reddest star ever found in the local galactic neighborhood. Calculating how long it has been cooling using spectroscopic and photometric data from the Gaia Dark Energy Survey and the X-Shooter instrument at the European Southern Observatory, astronomers found that the Air star with 145 is about 10.7 billion years old. They found that 2 billion years passed as a white dwarf cooling down. Spectroscopy involves analyzing light from the star at different wavelengths, which can detect that elements in the star's atmosphere absorb light in different colors, helping determine which elements are and how much is present. Analyzing the spectrum of WD-2147 4035, the team detected the presence of the metals sodium, lithium, potassium, and temporarily detected the carbon deposited on the star, making it the oldest metal-contaminated white dwarf ever discovered. The second blue star, which 1922-233, is only slightly younger than WD-2147 4035 and is polluted by planetary remains of a composition similar to Earth's continental crust. Despite its cold surface temperature, the science team concluded that WD-1922-233's blue color was due to its unusual atmosphere of helium-hydrogen mixture. The debris found in the nearly pure helium and high-gravity atmosphere of red star WD-2147 4035 belonged to an ancient planetary system that survived the star's evolution into a white dwarf, leading astronomers to conclude that it is the oldest planetary system around a white dwarf discovered in the Milky Way. Lead author Abigail Elms, PA student in the Department of Physics at the University of Warwick, said, "These metal-contaminated stars show that Earth is not alone, but that there are other planetary systems with Earth-like planetary bodies. 97% of all stars will turn into a white dwarf, and they're so common in the universe that it's especially important to understand these extremely cold ones. Cold white dwarfs, the oldest stars in our galaxy, provide insight into the formation and evolution of planetary systems around the oldest stars in the Milky Way. In the Milky Way, we find the oldest remnants of stars that were once contaminated by Earth-like planets. It's surprising to think that this happened over 10 billion years, and these planets died long before Earth formed." Astronomers can also use the star's spectrum to determine how quickly these metals sink into the star's core, allowing them to look back in time and determine how abundant each of these metals was in the original planetary body. By comparing these abundances with astronomical objects and planetary material found in our own solar system, we can predict what these planets might be like before the star dies and becomes a white dwarf. But in the case of WD-2145, this has proven difficult. Abigail explains, "The red star WD-2147 4035 is a mystery, as the deposited planetary remains are so rich in lithium and potassium and unlike anything known in our own solar system. It's a very interesting white dwarf because of its ultra-cold surface temperature. The metals that pollute it, fact that it's old, and being magnetic makes it extremely rare. Professor P.A. Emmanuel Tremblay from the Department of Physics at the University of Warwick said, "When these ancient stars formed more than 10 billion years ago, the universe was less metal-rich than it is now, as metals are formed in evolved stars and massive stellar explosions. The two observed white dwarfs. This provides an exciting window into planet formation in a metal-poor, gas-rich environment that differs from the conditions at which the solar system formed." This research received funding from the European Research Council, Leverhulme Trust Grant, and UK STUFC Consolidated Grant under the European Union's Horizon 2020 Research and Innovation Program. If you don't want to miss so much space-related news from us today, don't forget to like the video and subscribe to our channel. See you in another video. Goodbye. Hello, everyone. Scientists have had the opportunity to examine many celestial bodies that have remained in the dark by looking into the depths of space with the Hubble Space Telescope. This telescope, which became operational in 1990, has sent us many pictures of the universe that we can admire, from the pillars of creation to the rings of Saturn, cosmic reef, bullet cluster. According to a report published on the official website of NASA, scientists discovered a mysterious glow surrounding the solar system. No, this glow was not coming from a dying star or moonlight. Scientists are puzzled as to what this mysterious glow could be as a result of the analysis of Hubble data. So, what is the source of the light? When was the mysterious light discovered? Why is understanding this light source so important to physics and astronomy? Let's find the answers to these questions together. When you look up at the sky at night, you know that it is not completely dark. The permanent companion of our planet is the moon. Stars and planets shine like lamps in the dark sky, guiding us. On the other hand, we have a visual perception of the sky based on how the components reflect and emit light. So we have some idea of what's radiating in space. According to the sky luminosity data measured from Hubble images, the so-called zodiac light is the brightest among the lights shining in space because of the sunlight scattered by the interplanetary dust. Finally, all far ultraviolet and far infrared extragalactic photons, including light from stars, active galactic nuclei, and other objects, represent what we call extragalactic background light. He says none of these have any effect on the glow. Hubble captured these images as part of SkySurf, one of the telescope's largest programs that fully characterizes the brightness of the sky. NASA researchers announced that they discovered this ghostly glow after removing all the light from stars and planets. NASA announced that this discovered glow is equivalent to the glow of 10 fireflies spread across the entire sky. Still looks like finding an unexpected glow. Scattered skies account for more than 95 of the photons received by Hubble at wavelengths between 0.6 and 1.25 microns. Additionally, over 95 of the photons in Hubble images are known to come from distances closer than 3 or 4.8 billion kilometers. For many years, researchers using telescope data ignored these sky photons as they were more interested in other objects such as stars and galaxies. Ghostly glow could be sunlight reflecting off dust globules left behind by comets in the solar system, known to be filled with tiny dust and ice particles originating from a population of comets moving inward from the far reaches of the solar system. They blow out the exhaust, and then when sunlight falls on the remaining parts, They reflect the light, creating a diffuse glow. Interestingly, this ghostly glow isn't the first mysterious glow discovered. The New Horizons space probe launched successfully in 2006 to study the solar system's ninth planet, Pluto, flew 12,500 kilometers above the dwarf planet in July 2015, sending us stunning images of this vast world. New Horizons made observations 7.5 billion kilometers from the Sun. Spacecraft instruments detected faint light in the region beyond Pluto. Researchers expected to see such light due to the cosmic optical background, a faint glow emanating from light sources outside our galaxy. However, the light captured by the New Horizons instruments was almost twice as much as it should have been. It means there's some kind of extra light coming in. The glow captured by Hubble follows a different path than the glow detected by New Horizons. The light that stands closer to us is now brighter, and this makes the glow suggest that it must have developed due to some local event occurring within the solar system rather than associating it with something coming from outside. Given that the Voyager 1 space probe has caught a similar glow in the past, scientists in the SkySurf project aim to impose restrictions on extragalactic background light to make observations more precise. In the latest light measurements, scientists predicted there may be a significant number of missing faint galaxies, which could cause inconsistency. When they searched for hidden galaxies by stacking them on top, they concluded that there weren't enough galaxies missing to explain this ghostly light, thus increasing the possibility of interplanetary dust. Looking up at the sky helps us learn a lot about what's out there, from our solar system to the far reaches of the universe. And if there's a ghostly glow around it, makes everything a bit confusing and blurry. Analysis of the SkySurf data has been compiled in 4 research papers so far, and there are several more possibilities. New article expected to be published soon. All right, so far from us. What do you think is causing this ghostly glow? Is it a stray comet or interplanetary dust passing by from far away? For videos with content like this, don't forget to like our video and subscribe to our channel. See you in the next video. Hello, everyone. The Sun, our nearest star, is a magnificent celestial body that serves as the life-giving force for our planet. In this documentary, we embark on a journey to explore the dynamic nature of the Sun and its profound influence on Earth. From its fiery core to its mesmerizing surface and the intricate dance of solar activity, we uncover the wonders of our star and the vital role it plays in shaping our planet and sustaining life as we know it. The structure of the Sun. The Sun is a massive, hot ball of plasma composed mostly of hydrogen and helium. At its core, temperatures and pressures are so extreme that nuclear fusion occurs, generating vast amounts of energy. Surrounding the core is the radiative zone, where energy is transported through radiation, and the convective zone, where energy is carried by the movement of hot plasma. Above these layers lies the visible surface of the Sun, known as the photosphere. The Sun's atmosphere. The Sun's atmosphere consists of several layers, including the chromosphere, the transition region, and the outermost layer called the corona. The chromosphere emits a reddish glow during solar eclipses, while the corona, with its ethereal streamers, becomes visible during total solar eclipses. The corona, with its extremely high temperatures, is an area of intense scientific interest due to its unique properties and its role in the solar wind. Solar activity, sunspots and solar flares. The Sun is a dynamic star, constantly undergoing cycles of activity. Sunspots, dark patches on the surface, are regions of intense magnetic activity. They are cooler than their surroundings, but can still release enormous amounts of solar flares. Eruptions of magnetic energy are often associated with sunspots and can unleash massive bursts of radiation and particles into space. Understanding and predicting solar activity is essential for space weather, forecasting, and protecting our technological infrastructure. The solar wind and space weather. The Sun continuously releases a stream of charged particles known as the solar wind. This wind, carrying energy and magnetic fields, interacts with Earth's magnetosphere, causing space weather phenomena. Coronal mass ejections, large-scale eruptions of plasma and magnetic fields from the Sun, can disrupt satellites, power grids, and communication systems on Earth. Studying the Sun's influence on space weather helps us better prepare for and mitigate potential impacts. Solar influence on Earth's climate. The Sun plays a significant role in shaping Earth's climate. Variations in solar activity, such as changes in the Sun's brightness and the frequency of sunspots, can affect Earth's temperature and weather patterns. Scientists study past solar activity through ice cores, tree rings, and other natural records to understand the Sun's long-term influence on our climate. This research helps us differentiate between natural climate variations and human-induced changes. Solar energy, powering our planet. The Sun's abundant energy resources have inspired the development of solar power technology. Solar panels harness the Sun's rays, converting them into electricity without producing greenhouse gas emissions. Solar energy is becoming an increasingly important part of the global energy mix, offering a sustainable and renewable alternative to traditional fossil fuel sources. The Sun's energy potential is virtually limitless, providing a clean and abundant power source for future generations. The Sun, our dynamic star, is not only a source of light and warmth, but also a catalyst for life on Earth. From its complex structure and captivating surface features to its influence on space weather and climate, the Sun's impact on our planet is profound and far-reaching. Understanding the Sun's behavior and its role in shaping our world is not only crucial for scientific research, but also for mitigating potential risks and harnessing its incredible energy potential. As we continue to explore the mysteries of the Sun, scientists are constantly developing new instruments and technologies to study its intricate workings. Solar telescopes like the Solar Dynamics Observatory and the upcoming Daniel K. Inouye Solar Telescope provide us with unprecedented views of the Sun's surface, allowing us to observe solar flares, prominences, and other solar phenomena in exquisite detail. The study of the Sun is a collaborative effort with international space agencies and research institutions working together to unravel its secrets. Missions like NASA's Parker Solar Probe, which is journeying closer to the Sun than any previous spacecraft, provide us with valuable data about the Sun's atmosphere and its influence on the solar wind. These missions pave the way for future advancements in our understanding of our star and its impact on our planet. In conclusion, the Sun, our dynamic star, holds a central position in our solar system and plays a vital role in shaping our planet and sustaining life. From its structure and atmospheric layers to its influence on space weather, climate, and renewable energy, the Sun's influence reaches far and wide. Through ongoing research and technological advancements, we are unraveling the mysteries of the Sun, deepening our understanding of this awe-inspiring celestial body and harnessing its power for the benefit of humanity. As we gaze upon its radiant presence in the sky, let us appreciate the Sun's beauty, its significance, and the remarkable journey of discovery that lies ahead. So what do you think about this subject? Please do not forget to share your ideas with us in the comments section. Subscribe to our channel, turn on the bell notification, and be notified of upcoming videos. See you in another video.
Hello, everyone. Our home planet Earth is a place unlike any other planet. Earth, third in the solar system, is the only place in the universe where we know for sure that life exists. Let's just say that Earth is pretty unique when it comes to nicknames too. All the other planets in the solar system are named after Greek or Roman gods, but for at least 1,000 years some cultures have defined our world using the old Germanic word Earth, which simply means Earth. Earth was formed 4.6 billion years ago from the cloud of gas and dust that makes up our entire solar system, including our star, the Sun. Scientists hypothesize that this gas and dust collapsed into a disk, and different parts of the disk combine to form each of the planets in the solar system. According to NASA, our planet is located in a small corner of the Milky Way galaxy, 25,000 light-years from the galactic center. The solar system is located on a small arm called the Spur of Orion that separates from the Sagittarius arm, one of the galaxy's two large spiral arms. Earth's circumference is 40.75 kilometers, making it the largest rocky planet in the solar system. Our planet orbits 150,000 km from the Sun, giving it the right temperature for permanent liquid water on its surface. It is the only object known to orbit in this region, called the Goldilocks region. Also known as the habitable limit, is a scientific term for the theoretically possible region around a star for a planet with sufficient atmospheric pressure to hold liquid water on its surface. According to Caltech's Center for Infrared Processing and Analysis, Earth is made up of many elements, primarily oxygen, silicon, magnesium, iron, aluminum, and nickel. According to the U.S. Geological Survey, our planet's crust is a thin outer layer containing mostly silicate and basaltic rocks and extends an average of 30 km below the planet's surface. The mantle is the next layer that extends to about 2,900 km below the Earth's surface. A common misconception is that all the rock in the mantle melts into magma. In fact, most are in a highly viscous form that is so thick that it takes millions of years for movement to become apparent. According to the USGS, at the center of the Earth is a nickel-iron core that is liquid from the outside up to a depth of 2250 km, but is crushed by incredible pressures to form a solid at the lowest depths. Processes below the Earth's crust cause these continents to move over geological time periods. Geologists have discovered subterranean continents buried deep under the surface, and although no one knows exactly how or when they formed, they may be as old as the Earth itself. Like Venus and Mars, Earth has mountains, valleys, and volcanoes. But unlike its rocky brethren, almost 70% of Earth's surface is covered by oceans of liquid water at an average depth of 402,336 kilometers. These bodies of water include 97% of Earth's volcanoes and 64 mid-ocean ridge, a massive mountain range over 373.73.76 kilometers long. Earth's crust and upper mantle are split into huge plates that rub against each other in slow motion. As these plates collide, break apart, or slide past each other, our very active geology emerges. Earthquakes rumble as these plates slip against each other. Many volcanoes are formed when seafloor crust strikes continental crust and slides under it. When continental crustal plates collide, mountain ranges like the Himalaya are pushed into the sky. According to NASA, our planet's atmosphere consists of 70-80 nitrogen, 20 oxygen, 0.9 argon, 0.4 carbon dioxide, and traces of other gases. According to NASA, most human activity takes place in the troposphere, the lowest atmospheric layer that stretches 8 to 14.5 km above our heads. Above this is the stratosphere, where clouds and weather balloons fly and goes up to 50 km. This is the mesosphere, which extends to an altitude of 85 km, where meteorites burn, and is followed by the thermosphere, which extends to an altitude of at least 600 km. Human activities have a major impact on the climate and weather in the Earth's atmosphere. In the last 2 centuries, humans have added enough greenhouse gases to the atmosphere to raise the Earth's average temperature by 1 degree. This extra heat changed Earth's weather in many ways. The atmosphere not only nurtures life on Earth, it also protects it. It's thick enough to cause many meteorites to burn up before impact due to friction, and gases such as ozone prevent DNA, damaging ultraviolet light from reaching the surface. However, our atmosphere is surprisingly thin despite all that it does. 90% of Earth's atmosphere lies within just 1,609,344 km of the planet's surface. In addition, the atmosphere, the rotation of our planet, is shielded from the Earth's magnetic field produced by the iron-nickel core. This teardrop-shaped field protects the Earth from the Sun and high-energy particles thrown at us from elsewhere in the cosmos. But due to the nature of the field, some particles flow toward Earth's poles and collide with our atmosphere, creating auroras, the natural fireworks display known as the Northern Lights. Earth is tilted 23.4 degrees on its axis, which means sunlight falls on the planet's surface unevenly throughout the year, creating seasonal variations across much of the planet. But regions experience different variations in sunlight. So the Earth's surface is often divided into 3 main climate zones. According to Britannica, the highest point above sea level is the summit of Mount Everest at 8,849 meters. The crescent-shaped trench known as the Mariana Trench at the bottom of the western Pacific Ocean stretches up to 10,984 km, making it the deepest point on our planet. The Nile is the longest river in the world, meandering for 6,650 km through northeastern Africa. Lake Baikal in Russia is the largest and deepest freshwater lake, containing 23,013 cubic kilometers of water. This is approximately equal to the sum of the 5 North American Great Lakes. Earth is unique because it is the only place in the universe known to host life. Some of the earliest evidence of microbial life suggests it was already prevalent on our planet 3.95 billion years ago, Live Science previously reported. Exactly how these microscopic creatures emerged remains a mystery, but experts have put forward many theories. Scientists estimate that there are as many as 1 trillion species on our planet, living in niches stretching from the upper atmosphere to the depths of the rocky surface. Strange and complex biospheres exist around hydrothermal vents on the ocean floor and in nearly every rock and crevice ever discovered, Live Science previously reported. Whether this means organisms exist elsewhere in the solar system or beyond remains an open question, but the diversity of life on Earth has given scientists hope that life can exist in extreme environments in the universe. Earth is the planet where we have the best opportunity to understand in detail, which helps us see how other rocky planets, even those orbiting distant stars, behave. As a result, scientists are increasingly watching Earth from space. NASA alone has dozens of missions dedicated to unraveling the mysteries of our planet. At the same time, telescopes look outward to find other Earths. Thanks to instruments like NASA's Kepler Space Telescope, astronomers have found more than 3,800 planets orbiting other stars. Some of them are Earth-sized, and some orbit around their stars in regions with just the right temperature to be potentially habitable. Other missions, such as the Transiting Exoplanet Survey Satellite, are poised to find even more. As we always say, our planet is magnificent, and it is our duty to try to preserve this beauty as much as possible. The fact that we have nowhere else to go reveals the gravity of this situation. Don't forget to turn on the notification bell and like our video to be informed about the videos. See you in another video.
Hello, everyone. Now we want you to imagine a cat inside a closed box. Let us warn you from the beginning that these will not be one of the funny videos that make us laugh while watching the cats inside the boxes for entertainment purposes. If our unfortunate cat is in the box, let's put a radioactive element and a poison in the glass chamber in the box. Our work is not finished yet. Let's have a hammer attached to the Geiger counter on the glass chamber. Now let's get to our experiment. If the element were to radiate, the Geiger counter would detect it, and the hammer would strike the glass bowl, breaking it, and the poison would spill into the box, and our unfortunate cat would unfortunately die because of it. But if the Geiger counter detects no radiation, the hammer will not actuate, and therefore neither the glass nor the glass chamber will break. And our unfortunate cat will continue to live. An hour later, when we go to open the lid of the box, we will encounter a half-life cat, living or dead. What do you think will happen to the unfortunate cat? In quantum mechanics, our cat is considered both alive and dead as long as the box remains closed. So how is this possible? How can we learn the fate of the cat without opening the lid of the box? If you've ever wondered what will happen to our unfortunate cat, let's get started. If we know the position and velocity of the ball at any given moment when we hit a ball, we can calculate its future location using Newton's second law. Even if you say that there is no need to be such a formulary player while playing basketball, you intuitively know where the ball lands because you know actions such as the weather, your hitting hardness. This is how classical mechanics work. It never gives you a headache, but we cannot say the reassuring feeling of classical mechanics based on formulas for quantum mechanics. Our story begins with Louis de Broglie. Broglie asks Erwin Schrödinger every day to give a detailed explanation on the subject, after showing that there is not only photons, but a wave-particle duality, or wavelength, that is connected to every mass object. During Schrödinger's speeches, one of the other professors said, "You talk about good wave mechanics, but you don't have a mathematical equation. Can you achieve equality?" Thereupon, Erwin Schrödinger rolls up his sleeves and gets to work. Erwin, who prefers solitude during each of his works, disappears and emerges with a function that explains the wavelength in his hand after a process where he does not talk to anyone, and publishes his article Erwin Schrödinger, Entschleunigkeit and Quantum Theory. Our equation is this. We know it sounds a little scary, but don't worry, we're not going to review these terms one by one and confuse you further. All we need is what this equation does. This equation allows us to study what Schrödinger's wave function does for subatomic particles. Just like Newton's second law, which we used in the ball example, but in a more complex form that pushes the limits of our minds. Everything should be there so far, but there is a problem. We cannot observe asymmetrical wave function in the quantum world. When the measurement is made, there is a wave function appearing at a single point. But when we make an observation, we see it as a particle. What do you think could be propagating in these particles like a wavelength? If you can answer this question, congratulations. You may write your name in the history of science in gold letters and have to make room on your shelf for your Nobel Prize. Because this question, which cannot be answered, has been investigated by scientists for 100 years. When we put the values into this equation and run it, it gives a wave. Schrödinger interpreted this as the frequency of the density of the electron's charge. But he misinterpreted. Yes, he misinterpreted his own equation, for which he spent sleepless nights. And here came the famous mathematician Max Born, who played a role in the development of quantum mechanics. According to Born, what we got was a probability wave, and the outputs and indentations in that wave gave the probability of where the electron was. When we squared the result, we were able to obtain where and with what probability the electron was found. The reason for squaring is because the negative parts under the system cannot show a possibility. Although this equation is a function that is still valid today, isn't the result a bit strange? He shows that the universe is not deterministic, crushing the words of Einstein, who said God does not play dice. In short, there are two rules here. When you're not looking, the wave works, and Schrödinger's equation works perfectly. When we look at it, the wavelength function suddenly collapses and behaves as a particle. By squaring the results of Schrödinger's equation, we actually get the probabilities of where the particles are located. Oddly enough, Schrödinger himself hated this equation and came up with the thought experiment we know as Schrödinger's cat. Let's examine the details of this experiment in more detail. As we mentioned at the beginning of the video, we want you to think again. Imagine a cat, and you put it in a box with a small vial of poison and a radioactive element. The probability of the radioactive element radiating within an hour is equal to the probability that it will not. If the sensor we put inside the box detects a possible radioactivity situation, the small glass bottle containing the poison will be smashed by the mechanism and kill the cat. If the radioactive element does not radiate, the sensor will not work, and the mechanism will not trigger and shatter the bottle. Therefore, the confused cat inside will continue to live. This is where things go wrong in quantum mechanics. We cannot classify particles as radiating or not. It is in a state we call superposition. At the same time, the element kills the cat by radiating, and the cat continues to live by not radiating. As you guessed, this happens when we're not observing. When you wonder what happened to the cat and open the lid of the box, one of these possibilities is realized. In the experiment, when the box is closed, everything that has a wave function inside is in its superposition, both radiating and not radiating. So according to quantum mechanics, the cat is both alive and dead. How do you think these particles know that they are being observed? Or do they have a will that we don't know about? There is an experiment that argues that subatomic particles communicate in a time-independent manner and can change the past when information is erased, and it's called the double-slit and quantum eraser experiment. But let's discuss it in another video with quantum entanglement. Now, we would like to talk to you about another issue that wave mechanics brought us to. Parallel universes are a topic that everyone around us hears about and has positive or negative opinions about, and we are not the only ones discussing this issue. It also circulates among scientists, but it will remain a mystery until one of them discovers it. But now let us introduce you to Hugh Everett's theory of the multiverses in 1957. Let's remember our unfortunate cat in the box again. Until we opened the box, the molecules were both radiating and not in superposition. As soon as the molecules went into the superposition, our universe split in two, leaving it in a state where these two possibilities were realized. In one of the universes, Two separate universes were formed, in which the cat lived and in the other, where it died. This phenomenon is called branching. Our universe branched out into two different universes, and you don't know which universe you are in until you open the box. As soon as you can't resist your curiosity and open the box, you become a part of that universe. Let's say you and your consciousness are in a universe where the cat lives. There is another universe where the cat dies, but there is not you. You who are in the universe where the cat dies are as real as you who are in the universe where the cat lives. Think of it as if there is a different mathematical plane that you can never interact with. So the universe itself is a wave function. Your measurement does not collapse the wave function. Every possible possibility in the wave function actually takes place in a different universe. Everett's interpretation of quantum mechanics is a little difficult to understand because it's far beyond our state of perception. Our universe is branching out as each object goes into a superposition, and all of the situations happen in an absolute universe with equal probability. When Everett first came up with this interpretation, when great physicists like Niels Bohr downplayed and ignored the theory, Everett backed into his own corner with great disappointment. Although the new universes that are formed today cause great debates as to whether they are a physical reality or just mathematical possibilities on paper, there will definitely be people who believe until the opposite is proven. So what do you think about this subject? Is there a universe where everything is beautiful and independent of us? In fact, by seeing this video, you have created a branch in the universe. And somewhere in the universe, there is a state of you who click and watch the video. If you clicked on this video and watched it so far, it means you are in the right universe for us. Please do not think of creating new branches in the universe by sharing your comments with us. No matter which corner of the universe you are in, don't forget to subscribe to the channel and turn on the bell notification. See you in another video. Ladies and gentlemen, welcome back to our channel where we embark on an extraordinary journey through the cosmos. Today, we delve into a topic that has captivated the imaginations of people worldwide. NASA and aliens, visitors to our Earth. We will explore the realm of unidentified flying objects and ponder the possibility of extraterrestrial visitations that have left us both fascinated and perplexed. In recent years, there has been a surge of interest in UFO sightings and encounters. People from all walks of life have reported seeing strange objects in the skies, exhibiting flight patterns and characteristics that defy our current understanding of aviation technology. But what are these mysterious objects? And could they be evidence of intelligent life from other worlds? NASA, the renowned space agency at the forefront of scientific exploration, has not been immune to encounters with UFOs. Over the years, NASA astronauts and personnel have shared accounts of unexplained phenomena witnessed during space missions. These accounts have sparked widespread curiosity and fueled the debate about the existence of extraterrestrial life. One of the most notable cases involving NASA and UFOs is the Apollo 11 mission, which landed humans on the moon for the first time. During their lunar excursion, astronauts Neil Armstrong and Buzz Aldrin reported seeing peculiar objects and lights that seemed to follow their spacecraft. These incidents, captured in audio transmissions, have become the subject of intense speculation and scrutiny. In recent times, NASA has taken a more open approach to UFO investigations. The agency has acknowledged the presence of unidentified aerial phenomena and has initiated studies to better understand these encounters. In fact, in 2020, the United States Department of Defense officially released several videos captured by military pilots showing encounters with unidentified objects exhibiting extraordinary flight capabilities. While these videos do not provide conclusive evidence of extraterrestrial origin, they have renewed public interest and raised important questions about the nature of these unidentified objects. Are they advanced aircraft developed by other nations? Or could they possibly be vehicles from civilizations beyond our planet? The possibility of intelligent life visiting Earth from distant star systems has fascinated scientists, ufologists, and enthusiasts alike. The vastness of the cosmos, with its billions of galaxies and trillions of stars, makes it statistically probable that other intelligent beings exist in the universe. And if they do, it is not unreasonable to consider that some of them may have developed the technology to traverse vast cosmic distances and explore other worlds. The Fermi paradox, named after physicist Enrico Fermi, raises an intriguing question. If the universe is teeming with intelligent life, why haven't we encountered any clear evidence of it yet? This paradox, often contemplated by scientists, fuels the search for answers and drives our exploration of the possibility of extraterrestrial visitations. NASA has also played a pivotal role in the search for extraterrestrial intelligence. Through radio telescopes, scientists listen for potential signals and transmissions from civilizations beyond Earth. While we have not yet detected a confirmed extraterrestrial signal, the search continues, driven by the curiosity and determination to unravel the mysteries of the universe. But what about the countless UFO sightings reported by individuals worldwide? Are they all hoaxes or misidentifications? While it is crucial to approach these claims with skepticism, it is equally important to maintain an open mind. Some sightings defy conventional explanations, and genuine mysteries persist. In recent years, the U.S. government has taken steps to investigate these sightings more seriously. The establishment of the Unidentified Aerial Phenomena Task Force within the Pentagon, along with the release of declassified UFO videos, demonstrates a growing recognition of the need for further exploration and understanding. However, it is important to approach the subject of UFOs and extraterrestrial visitations with scientific rigor and critical thinking. Not every unidentified object is a spacecraft from another world. Many UFO sightings can be attributed to natural phenomena, misinterpretations, or even secret military projects. It is crucial to separate genuine anomalies from misconceptions and misinformation. In our quest for the truth, scientists and researchers continue to investigate UFO sightings using rigorous methodologies. They analyze photographic and video evidence, interview witnesses, and study patterns and characteristics of reported sightings. Through these investigations, some cases have been explained as atmospheric phenomena, optical illusions, or misidentifications of conventional aircraft. Nevertheless, there remain intriguing cases that defy easy explanation. These instances challenge our understanding of the world around us and keep the door open to the possibility of extraterrestrial involvement. Scientific scrutiny and a meticulous examination of evidence are vital in distinguishing between genuine encounters and misunderstandings. The question of whether we have been visited by intelligent beings from other worlds remains unanswered. Despite the intriguing accounts and unexplained phenomena, conclusive evidence of extraterrestrial visitations has yet to be presented. However, the absence of definitive proof should not diminish our curiosity or our pursuit of knowledge. As we continue to explore the vast expanse of the cosmos, our understanding of the potential for life beyond Earth expands. The discovery of exoplanets within habitable zones and the existence of extremophiles on our own planet demonstrate that life can thrive in diverse and extreme environments. These findings increase the likelihood that life may exist elsewhere in the universe, and the search for it continues. NASA and other space agencies are actively engaged in missions and projects aimed at detecting signs of life beyond Earth. Whether through the study of Mars, the exploration of icy moons in our solar system, or the development of powerful telescopes, scientists are dedicated to unraveling the mysteries of the cosmos and uncovering the truth about our place in the universe. In conclusion, the topic of UFOs and the possibility of extraterrestrial life remains a subject of great fascination and debate. NASA's involvement, along with the release of compelling videos and the ongoing search for extraterrestrial intelligence, contributes to the exploration of these mysteries. While we may not have definitive answers yet, our quest for knowledge and our insatiable curiosity continue to drive us forward. We must approach the subject with a balanced perspective, embracing scientific inquiry and critical thinking. By doing so, we honor the spirit of exploration and ensure that our search for the truth is guided by evidence and reason. Thank you for joining us on this fascinating journey into the world of UFOs and the possibility of life beyond our planet. Don't forget to subscribe to our channel, turn on the bell notification, and stay tuned for more thought-provoking discussions and universe exploration. Until next time, keep looking up, because the wonders of the universe are waiting to be discovered. Welcome, space enthusiasts, to another captivating journey through the cosmos. Today, we turn our gaze towards one of humanity's most iconic and game-changing astronomical tools, the Hubble Space Telescope. Prepare to be enthralled as we take a candid and in-depth look at this technological marvel that has revolutionized our understanding of the universe. A rocky start. The Hubble Space Telescope, named after the renowned astronomer Edwin Hubble, embarked on its celestial journey on April 24, 1990. However, it was not a smooth takeoff for our intrepid explorer. Shortly after its deployment, it became clear that the telescope suffered from a severe optical flaw, leaving astronomers dismayed and frustrated. The images it transmitted were blurry and far from the crystal clear vision it was intended to provide. A bold rescue mission. Enter a team of brilliant minds and daring engineers who refused to let the Hubble's initial setback be its undoing. In 1993, astronauts aboard the Space Shuttle Endeavour embarked on a daring mission to service and repair the Hubble. The meticulous work involved replacing key components, including the primary mirror, effectively correcting the telescope's vision. This dramatic and unprecedented rescue mission would pave the way for the awe-inspiring discoveries that were yet to come. Unveiling the cosmos. With its newfound clarity, the Hubble Space Telescope commenced its mission in earnest. Its stunning images captured the imagination of people worldwide, unveiling breathtaking cosmic vistas previously unseen. From swirling galaxies and dazzling nebulae to celestial fireworks and colliding galaxies, the Hubble opened up a window to the wonders of the universe. Peering into the depths of time. One of the Hubble's most remarkable achievements is its ability to gaze deep into the past. By observing objects billions of light years away, the telescope enables us to peer back in time, providing crucial insights into the early universe. The Hubble has contributed to our understanding of the cosmic microwave background radiation, allowing us to glimpse the remnants of the Big Bang and unravel the mysteries of the universe's origins. Unraveling stellar mysteries. The Hubble Space Telescope has been an invaluable tool in studying stars at all stages of their lives. It has captured the birth of new stars within vast clouds of gas and dust, unveiling the intricate dance of gravity and nuclear fusion that gives rise to these celestial objects. Moreover, it has shed light on the explosive deaths of massive stars, witnessing the cataclysmic supernovae that mark the end of their stellar journeys. Unveiling exoplanetary world. Another groundbreaking aspect of the Hubble's mission is its contribution to the field of exoplanet exploration. By studying the faint dimming of starlight as planets pass in front of their host stars, the telescope has helped identify and characterize thousands of exoplanets. From scorching hot Jupiters to potentially habitable rocky worlds, the Hubble has expanded our knowledge of the diversity and abundance of planetary systems beyond our solar system. A legacy of discovery. As the years passed, the Hubble Space Telescope continued to deliver awe-inspiring images and groundbreaking scientific findings. Its contributions to our understanding of dark matter, dark energy, and the evolution of galaxies have reshaped our cosmic worldview. Furthermore, the Hubble has acted as a springboard for future space missions, inspiring endeavors such as the James Webb Space Telescope, which promises to unveil even deeper cosmic mysteries. Advancements and upgrades. The success of the Hubble Space Telescope can be attributed not only to its initial repair, but also to subsequent servicing missions. Throughout its lifespan, dedicated crews of astronauts visited the telescope to conduct repairs, install new instruments, and upgrade its capabilities. These missions ensured that the Hubble remained at the forefront of astronomical research, continually pushing the boundaries of our knowledge. A global collaboration. The Hubble's impact goes beyond scientific discovery. It has become a cultural icon, captivating the hearts and minds of people around the world. Its mesmerizing images have graced the pages of books, adorned posters and calendars, and inspired countless artists and musicians. The telescope has fostered a sense of unity and wonder as people from all corners of the globe marvel at the beauty and vastness of the cosmos. Conclusion. The Hubble Space Telescope stands as a testament to human curiosity and ingenuity. Despite a rocky start, it has emerged as a beacon of scientific achievement, forever altering our perception of the cosmos. Its images and data have not only enriched our knowledge of the universe, but have also captivated our collective imagination, inviting us to ponder the vastness and beauty of the cosmos. As we bid adieu to this remarkable instrument in the coming years, let us celebrate its legacy and eagerly anticipate the next chapter in humanity's quest to unlock the secrets of the universe. The Hubble Space Telescope has truly revolutionized our understanding of the cosmos and left an indelible mark on the annals of scientific exploration. Please share your thoughts about the Hubble telescope, which changes our view of space with every new photo it sends us, in the comments section. What do you think will happen to Hubble? As Hubble makes new discoveries, we will be happy to report these developments to you. If you turn on the bell notification and subscribe to the channel, you can be informed about these exciting developments in seconds. See you in another video.
Hello, everyone. The sun is one of the most powerful feelings we can feel. Starting from the first light of the morning until the following hours, the warmth we experience on our skin gives life to the whole world simultaneously. As a source that makes us love nature and makes us feel survivors, she hides it from her surroundings every day. The cost to the sun is our feelings that we are connecting with something much greater than ourselves, which has existed for billions of years and will continue to exist long after we see it destroyed. With its distant character seen as the symbol of hope on Earth, this gigantic ball of gas is almost hot, chaotic, and hostile. We say it is hostile because Mercury, which is only 58 million kilometers away from the sun, is one of the unlucky planets as it sees the destructive effects of the sun. During the long Mercury days, the temperature rises to 430 degrees Celsius, enough to melt lead. However, the thin layers of the atmosphere cannot trap the heat, and the temperature drops to 180 dSec at night. No other planet in the solar system has such a temperature difference. Up close, isn't it so invigorating? Fortunately, thanks to the Earth's magnetic field, we are largely protected from the sun's destructive effects. But last week, the National Aeronautics and Space Administration announced that there are 20 Earth-sized holes in the sun's corona. The giant hole in question can send solar winds to the Earth at a speed of 2,896,000 kilometers. Scientists spend quite a lot of research on how this hole will affect our world, with you before the solar winds hit to spread out. In this video, we'll explore some amazing features of the sun, swaying in the solar winds, and learn what waits us Earthlings as a result of that wind. Sit back, relax, and let's dive into the fascinating creatures of the sun. Formed by the collapse of a molecular cloud about 4.6 billion years ago, our sun consists of a dense gas mixture. Thanks to its immense gravity, it not only holds helium and hydrogen together, but also has enough force to keep the planets in its orbit in a certain orbit. The sun is thought to be not very large compared to red giants, the largest known star type, but rather large compared to red dwarfs, the smallest star type. In short, although the sun is not the largest type of star in the universe, it is larger than most stars. With these qualities, the sun is just an old, average star by universal standards. The diameter of the sun is 1.4 million kilometers. The sun, 110 times larger than the Earth's diameter, has a volume equivalent to 1 million times the Earth's volume. It is a sphere of gas like other stars. It consists of 91.0 hydrogen and 8.9 helium in terms of atomic number. The enormous mass of the sun is held together by the force of gravity. It generates a tremendous pressure and a high amount of temperature in its center. The sun has 6 regions: the core, the radiative region, and the inner convective region. The visible surface called the photosphere, chromosphere, and the outermost region, the corona. In the core, the temperature is about 15 million degrees Celsius, which is enough to sustain thermonuclear fusion. This is a process where atoms combine to form larger atoms and release large amounts of energy in the process. Specifically, in the sun's core, hydrogen atoms combine to form helium. The energy produced in the core powers the sun and produces all the heat and light emitted by the sun. The surface of the sun we can see is about 5,500 degrees Celsius. That means much cooler than the burning core, but still hot enough to boil carbon like diamond and graphite, not just melt it. What prevents the sun from collapsing on itself is the conversion of hydrogen in the sun into helium through the fusion reaction and the energy released in the process. This is why hydrogen is said to be the fuel of the sun. When this fuel runs out, the sun will die too, scattering material to form even larger elements. But don't worry, this hot plasma is expected to die after 5 billion years. Now that we're talking about the solar core, let's get a little closer to the surface. The photosphere, the surface of the sun, is a 500-kilometer, thick region where most of the solar radiation escapes. This is not a solid surface like the surfaces of planets. Instead, it is the outer layer of the star, consisting of gas. We see radiation from the photosphere as sunlight when it reaches Earth about 8 minutes after leaving the sun. The temperature of the photosphere is about 5,500 degrees Celsius. The temperature of the chromosphere, which can reach about 2,000 kilometers from the photosphere, can rise from 6,000 decks to 20,000 dec. The reason why the sun appears red during total solar eclipses is that the hydrogen atom glows reddish at high temperatures in this region. The high temperature of the chromosphere is thought to originate from the photosphere. The corona layer can only be observed during total solar eclipses. Although we do not have certain information about why the corona layer, which has an average temperature of 2 million Kelvin, is so hot, it is thought that the magnetic field of the sun is effective in this situation. The surface of the sun is a moving field. The electrically charged gas creates a strong magnetic field. The gases in the sun are constantly moving, which entwines, stretches, and bends magnetic fields. This motion creates a lot of activity on the sun's surface, which is called solar activity. Sunspots appear as dark areas on the sun's surface. They appear dark because they are colder than other parts of the sun. Yet the spots are still very hot, approx 3,600 degrees. Why are sunspots relatively colder? Because the magnetic field in their region is particularly strong. These magnetic fields are so strong that they prevent some of the heat inside the sun from reaching the surface. Magnetic field lines near sunspots often become entangled, crossed, and rearranged. This causes sudden bursts of energy called solar flares. Explosions scatter large amounts of radiation into space. If the explosions are too intense, the emitted radiation can disrupt radio communications on Earth. Solar flares are sometimes accompanied by a coronal mass ejection. Mass ejections are large bubbles and particles of radiation from the sun. When the sun's magnetic field lines are suddenly rearranged, they explode and spread out into space at very high speed. Charged particles reaching the Earth from the mass ejection cause natural radiations called aurora in the sky. When the mass ejection is too strong, it can cause power outages in the worst case. Solar flares and coronal mass ejections are the most powerful eruptions in our solar system. The sun doesn't always behave the same way. The solar cycle has phases. About every 11 years, the sun's geographic poles change their magnetic poles. When this happens, the sun's photosphere, chromosphere, and corona changes from quiet and calm to fiercely active. The height of solar activity, known as the solar maximum, is the time of solar storms. Sunspots, solar flares, and coronal mass ejections increase. These are caused by irregularities in the sun's magnetic field. Some solar winds can even release large amounts of energy and particles that reach Earth. This space weather can damage satellites, erode pipelines, and affect power grids. The U.S. National Aeronautics and Space Administration detected a second dark spot on the sun's surface within a week. This black spot, called a coronal hole about 20 Earth-sized, is not dangerous to our planet, but may have some impact on Earth. The coronal hole is expected to send solar winds towards the Earth at a speed of 2,896,000 kilometers per hour. But don't worry, it was stated that these winds do not pose a threat to the world. Scientists announced that the winds expected to reach the Earth on Friday will not damage the electronic infrastructure, but will only create the northern lights in some regions. Chaotic, deadly, uncontrollable. Despite its devastating effects, the sun continues to give us life for centuries. When it gets old enough, as a result of the depletion of hydrogen atoms in the core, the helium atoms accumulating there will become unstable and begin to collapse. This will cause the core to heat up and condense, and the sun will become larger and larger. Entering its fate is called the red giant branch. As a result of this expansion, the sun will engulf Mercury, Venus, and perhaps Earth in its orbit. What a bitter end. That's all from us for today. If you want to see more sun-related content, you can continue to follow our channel. You can also share with us any sun-related topics that you would like to be addressed in the future in the comments section. Thank you for supporting us, and see you in our next video.
Ladies and gentlemen, welcome back to our channel, where we delve into the fascinating world of space exploration. In today's episode, we bring you an intriguing revelation from NASA scientists that could change our understanding of the moon forever. Get ready to uncover the possibility of microbial life hiding in the dark craters of the moon's south pole. For decades, the moon has captivated humanity's imagination. It has been a symbol of mystery and wonder, and we have long pondered the question of whether life exists beyond our own planet. While the moon is often perceived as a barren and desolate world, recent scientific findings have challenged this notion, revealing the potential for microbial life lurking in the most unexpected places. NASA's lunar missions, including the Lunar Reconnaissance Orbiter and the Artemis program, have provided valuable insights into the moon's composition and geology. These missions have enabled scientists to study the moon's surface in unprecedented detail, uncovering a treasure trove of information about its history and potential habitability. One of the most intriguing discoveries is the presence of water ice in the permanently shadowed regions of the moon's south pole. These regions, known as cold traps, are areas where sunlight never reaches, creating a perpetually dark and frigid environment. It is within these dark craters that scientists believe the conditions may be favorable for microbial life to exist. Water is an essential ingredient for life as we know it. Its presence on the moon opens up the possibility that microbial organisms, known as extremophiles, could have adapted to survive in the harsh lunar environment. These extremophiles are capable of withstanding extreme temperatures, low levels of nutrients, and high levels of radiation, making them resilient and adaptable to challenging conditions. The concept of life existing in such extreme environments is not new to science. On Earth, we have discovered life thriving in the most inhospitable places, such as deep sea hydrothermal vents, acidic hot springs, and even within the icy depths of Antarctica. These discoveries have expanded our understanding of the limits of life and its potential to exist in environments once considered uninhabitable. The moon's south pole offers a unique opportunity for exploration. Future missions, such as Artemis, aim to send astronauts to the lunar surface to conduct in-depth studies and collect samples. By analyzing these samples, scientists hope to uncover evidence of microbial life or signs of past biological activity, providing a groundbreaking confirmation of life beyond Earth. The search for life on the moon is not just a scientific endeavor, but also a stepping stone in our quest to understand the broader question of the existence of life in the universe. If microbial life is found on the moon, it would have profound implications for our understanding of the origins and prevalence of life throughout the cosmos. It is important to note that the search for lunar life is a complex and challenging task. The delicate nature of biological samples and the potential for contamination require meticulous protocols and careful analysis. Scientists must take every precaution to ensure the integrity of the samples and the accuracy of their findings. While the existence of microbial life on the moon is still a hypothesis, the tantalizing evidence and the ongoing exploration efforts fuel our curiosity and ignite our sense of wonder. The moon, once seen as an isolated and lifeless world, may hold the key to unlocking the secrets of our own origins and the potential for life elsewhere in the universe. As we continue to explore the moon and push the boundaries of our knowledge, we must remember the significance of these discoveries. They remind us of the boundless nature of the cosmos and challenge us to think beyond the confines of our own planet. They invite us to embrace the unknown and continue our quest for answers. In conclusion, the possibility of microbial life hiding in the dark craters of the moon's south pole opens up a new chapter in our understanding of the moon and its potential for habitability. The presence of water ice and the unique environment of the cold traps provide a promising avenue for the existence of microbial organisms capable of surviving in extreme conditions. As we embark on future lunar missions, armed with advanced technology and a deeper understanding of the moon, we have the opportunity to unravel the mysteries that lie within its craters. The Artemis program, with its ambitious goals of returning humans to the lunar surface, will pave the way for further exploration and scientific investigation. Through the collection and analysis of samples from the moon's south pole, scientists will meticulously study the chemical composition and search for signs of life. State-of-the-art instruments and laboratory techniques will be employed to detect any traces of organic molecules or biological activity. Every piece of data will be scrutinized, every hypothesis tested, as we seek to uncover the truth hidden beneath the lunar surface. The implications of discovering microbial life on the moon extend far beyond our celestial neighbor. It would fundamentally alter our understanding of the conditions necessary for life to emerge and thrive. It would challenge the notion that life is confined to Earth and open up the possibility that life may exist in unexpected and unconventional environments throughout the universe. Moreover, the discovery of lunar life would have profound implications for future space exploration and colonization. Understanding the survival mechanisms of these organisms in extreme conditions could provide valuable insights for sustaining human life in space and on other celestial bodies. However, it is crucial to approach this topic with scientific rigor and avoid jumping to conclusions. While the potential for microbial life on the moon is tantalizing, it is imperative to follow stringent protocols and conduct thorough investigations to validate any findings. The scientific community understands the importance of skepticism, peer review, and replication in ensuring the reliability of scientific discoveries. As we embark on this journey of exploration and discovery, it is essential to remember that the search for life on the moon is a testament to human curiosity, ingenuity, and the relentless pursuit of knowledge. It represents our inherent desire to understand our place in the cosmos and unravel the mysteries that lie beyond our home planet. In closing, the possibility of microbial life hiding in the dark craters of the moon's south pole is an extraordinary proposition that challenges our preconceived notions of the lunar environment. The ongoing efforts of NASA and other space agencies around the world to explore the moon and search for signs of life are pushing the boundaries of human knowledge and fueling our collective imagination. We stand on the precipice of a monumental discovery, one that could reshape our understanding of life's origins and the potential for life beyond Earth. As we gaze at the moon in the night sky, let us marvel at its hidden secrets and eagerly await the revelations that future missions will unveil. The moon, our celestial companion, holds the promise of unlocking the enigma of life in space and forever changing our perception of the universe we call home. We have come to the end of our topic today. If you liked the video, please do not forget to subscribe to the channel and turn on the bell notification. See you in the next video. Hello, everyone. At night, we see an endless darkness in the sky with twinkling stars to come. But is space really an endless corridor of darkness? Or can we see other colors? In fact, they have had color since they first appeared in the observation field. The universe is bathed in a sea of light, from the blue-white glow of young stars to the crimson glow of hydrogen clouds. Beyond the colors that the human eye sees, the colors created by the flashes of X-rays and gamma rays, powerful radio bursts, and the cosmic microwave background still shine in the background. Although they are faintly present, the universe has an ever-present glow. The cosmos is full of colors seen and unseen, old and new. However, among all this, there was a color that emerged before the others. So what was the first color of the universe? In today's video, we will explore the color of the room with you. Come on in. The universe began 13.8 billion years ago with the Big Bang. In its first moment, it was more intense and hot than it would ever be again. The Big Bang is often visualized as a bright flash of light appearing in a dark sea, but this is not an accurate picture. The Big Bang did not explode in empty space. The Big Bang was an expanding space filled with energy. After the Big Bang, there was no light because the temperature in the universe was so high. The universe had to cool before light rays appeared. 10 seconds after the Big Bang, the universe entered the photon era. Protons and neutrons cooled enough to form hydrogen and helium nuclei, and the universe. Nuclei became filled with electrons and photons. The temperature of the universe at that time was about 1 billion degrees Celsius. However, although there was light, there was no color yet. Color is something we can see, or at least something that some kind of eye can see. During the photon period, temperatures were so high that light could not penetrate the dense plasma. The color would not appear until the nuclei and electrons had cooled enough to bind to the atoms. It took 380,000 years for the universe to cool enough for the colors to appear. Until then, the observable universe was a transparent cosmic cloud of hydrogen and helium 84 million light-years across. All the photons formed in the Big Bang were finally released in space and time. This is what we now see as the cosmic microwave background. A flash of light from a time when the universe was finally visible. After billions of years, the universe cooled to a temperature 3 degrees less than absolute zero. The early universe was about 3,300 degrees Celsius, so it was filled with a bright and warm glow. People can't see colors very accurately. The color we perceive depends not only on the true color of the light, but also on its brightness and whether our eyes adapt to the dark. If we could go back to that first period of light, we would probably only be able to perceive a glow similar to the orange color emitted by fire. After the first light phase, the universe continued to cool and expand for several 100 million years. As the cooling and expansion continued, a pale orange color appeared. However, at the end of this process, the universe turned black. About 400 million years later, the first stars began to appear. The first stars brought their own light with them, radiated bright blue, white colors. As stars and galaxies emerged and developed, the universe began to take on a new color. Over the past years, Carl Glazebrook and Ivan Baldry have calculated the average color of all the light we see from stars and galaxies to determine the current color of the universe. This color turned out to be a pale complexion similar to a creamy brown color. They called this color cosmic latte. This cosmic latte color of the universe will last for a while like other colors. As large, blue stars age and die, the dark red light of dwarf stars will remain in the universe. After trillions of years, these lights will go out and the universe will turn into a dark sea. All colors will fade with time, and time will carry us all into darkness. But for now, the eye-catching colors of the universe continue to paint us. And if you ever sit by the fire and gaze into the night while sipping your creamy coffee, know that you are bathed in cosmic colors. We continue our intergalactic news from where we left off. Analysis of the most energetic light in the galaxy has revealed that we may be wrong about the rate of star formation in the Milky Way. Gamma rays, produced by the radioactive decay of isotopes produced during star formation, reveal that stars form at a rate of 4 to 8 times the mass of the Sun per year. This may not seem like much to you, but it is 2 to 4 times more than current estimates and suggests that our home galaxy is not as calm as we thought. Because the rate at which stars are born and die can change a galaxy's overall chemical composition, this has important implications for our understanding of the evolution of our galaxy and those around us. An article describing the finding, led by astrophysicist Thomas Seeger of the University of Würzburg in Germany, has been accepted for publication in Astronomy Astrophysics. Stars are factories that produce the more complex elements of our universe. Their nuclei are nuclear furnaces, and they smash atoms together, turning them into larger atoms. When they die, the throes of death blast these heavier elements into interstellar space to drift in clouds or take place in new stars that are forming. Supernova explosions are also energetic and create even heavier elements that their nuclei cannot support. Like their deaths, their star birth is energetic. They form in dense clumps and clouds of interstellar dust and gas, collapse under gravity, and greedily swallow material from the space around them until there is enough pressure and heat in their cores to ignite fusion. In doing so, they begin to emit powerful stellar winds that blow particles into space, and jets ejected from the poles of the accelerating particles through the baby star's magnetic field. One element known to result from stellar death is a radioactive isotope of aluminum called aluminum-26. Is not cosmically long-lived. It has a half-life of 717,000 years. It also produces gamma radiation of a certain wavelength while it dissipates, but aluminum-26 is also found in significant amounts in clouds of material surrounding newly formed stars. If the velocity of material falling into a star exceeds the speed of sound, a shock wave is produced that produces cosmic rays. When the rays collide with isotopes such as aluminum-27 and silicon-28 in the powder, it can produce the aluminum-26 isotope. So by looking at the budget of gamma radiation in the universe produced by the radioactive decay of aluminum-26, astronomers can estimate the rate at which stars producing this isotope form and die in the Milky Way, and use this to determine an overall rate of star formation. Current estimates of the star formation rate of the Milky Way galaxy are that about 2 suns worth of material turns into stars each year. Since most of the stars in the Milky Way are much less massive than the Sun, this is estimated to average 6 or 7 stars a year. Seeger and colleagues took account of aluminum-26 gamma radiation in the galaxy and modeled it to see the most likely production mechanism for the observed abundance of this light. They found that the best fit was a star formation rate of about 4 to 8 solar masses per year, or up to about 55 stars per year. There is still room for improvement in this estimate. Models did not exactly reproduce the Milky Way's gamma radiation as currently observed, and the distance from the gamma ray source may change the final estimate but are difficult to measure. Therefore, the researchers were only able to give a range for the rate of star formation rather than an exact mass. However, the team's method holds promise for better understanding how the Milky Way forms new stars. Star formation is often shrouded in thick gas and dust difficult to see inside. Counting the gamma radiation it produces can be an effective way of looking behind the curtain. That's all from us for today. Don't forget to subscribe to our channel and like our video for videos with such content. See you later.
Hello everyone! Throughout human history, the sky has been a source of deep inspiration for people. It has ranged from the first myths to Hollywood movies, from space exploration to the space travel of astronauts. Light pollution, a striking result of modernization, is our insidious enemy behind our inspiration. A study led by Noir Lab, the U.S. Nocturnal Astronomy Research Center, predicts that a child born today, in a place where 250 stars can be seen, will only be able to see 100 stars by the age of 18. Even today, due to the level of light pollution, 30 of people worldwide are deprived of night vision, and 80 of people in the United States are deprived of viewing their main galaxies at night. So what does it mean for the rate of visible stars to decrease in the coming years? How will the disappearance of stars affect us? In a public-based science program called Globe at Night, conducted by Noir Lab of the American Science Foundation, it has been determined that the stars are rapidly disappearing from the field of view of people. According to the research, artificial lighting, applied when it gets dark, shows that people are blinded to the sky. In fact, this blinding is happening even faster than satellite measurements show. The study, published last week, shows how ordinary people can contribute to important research areas. The new research, based on population-based science, sheds light on the problem of sky glow, a type of light pollution that causes the sky to become widely illuminated at night. And the researchers stress that we need to redouble our efforts to protect the night sky from this phenomenon. If change continues at this rate, children born in a place where 250 stars can be seen will only be able to see as many as 100 stars by the time they turn 18, says researcher Christopher Kaiba, who works at the German Geosciences Research Center and is the lead author of the paper in which the results are presented. So what is the sky glow? Looking at the sky with the naked eye on a clear and dark night, thousands of stars can be seen, from the shining belt of the Milky Way galaxy to the chaotic constellations. But with increasing light pollution, overgrouping of light sources such as Times Square, New York, causes the urban sky to shine. Street lamps, huge billboards, even the light we turn on in our room causes light pollution. Experts have long known there was a problem, but observations from the globe at night show that Earth's brightness at night is increasing at a much faster rate than is shown by satellite measurements. The study is based on crowdsourced reports where people from around the world post their findings online. Researchers are shown a series of star maps and are asked to record the one that best fits what they can see in the sky, providing an estimate of what is known as the limiting magnitude visible to the naked eye. The apparent magnitude is a measure of the brightness of a star or other astronomical object observed from Earth. The apparent size of an object depends on its intrinsic luminosity, its distance from Earth, and the extinction of the object's light caused by interstellar dust along the observer's line of sight. Globe at Night's findings are based on more than 50,000 observations sent from Europe and North America between 2011 and 2022. Why should this concern me? Humans have had an awe-inspiring view of the starry night sky throughout history, but the path we're taking now means that more and more people will lose it. Light pollution not only spoils the appearance of the sky, but also affects wildlife and our health. In nature, many animals that live actively at night need light from the sky at night. For example, unnecessary lighting of forests, lakes, and fields. It can lead to a decrease in beneficial insects living in the dark and the emergence of harmful species. And in the same straw, the migratory routes of insects can have a negative effect. Newly hatched caretta puppies, on the other hand, are affected by the strong artificial light coming from the coastal lights, and they can never reach the sea by going in the wrong direction. While the spawning period of fish changes under the sea, it is reported that birds migrating in the sky are affected by strong light and fly around skyscrapers and lighthouses until they are exhausted. Finally, it is worth noting that not only animals but also plants need starlight at night. The duration and amount of light determine not only photosynthesis, but also different developmental patterns. Excess light causes deformations such as deformation of plants, thickening of stem and cell wall, increased branching, and physiological deterioration such as decrease in chlorophyll, increase in respiration, and early flowering. It is unnatural for the sky to shine as it disrupts the cyclical transition from sunlight to starlight, where biological systems co-evolve. The apparent loss of stars reported by the globe at night represents a 9.6 yearly increase in sky brightness over the past decade, much more than the two measured by satellites, and in emerging markets where artificial lighting prevalence is increasing at a higher rate. This shows that existing satellites are not sufficient to study how Earth's night is changing, said study lead author Christopher Kaiba of the German Geosciences Research Center. If we do not do something about this inevitable enemy in the years to come, the negative impact of the sky glow on the ecosystem will be inevitable. The increase in sky glow over the past decade highlights the importance of redoubling our efforts and developing new strategies to protect dark skies. The Globe at Night dataset is indispensable for us to continually assess changes in sky luminosity, and we encourage anyone who can participate to help preserve the starry night sky. What do you think about the disappearance of so many stars from us today? Please share with us in the comments section. Don't forget to subscribe to our channel and ring the bell for more videos with this type of content. See you later!